is thermochemistry, which is a part of thermodynamics only. Okay. So entropy. What is meant by entropy of a system? It represents, okay, so 1, 2, 3 RDM. Okay, so R stands for randomness of a system. Okay, so what is meant by randomness? Randomness means what? Randomness means we don't know how atoms and molecules they are arranged. Are you able to understand? They do not have a regular pattern. That type of arrangement is called as randomness. Are you able to understand? D stands for disorderness. Okay, there is no particular order in the system. Are you able to understand? And M stands for mixing, which is present in the system. For example, if I mix two gases, then it is called as mixing of gases. No? So therefore, entropy represents these values. It represents randomness of a system, how random the molecules and atoms they are arranged, and disorderness of a system, what is the order which is not present in a system. Are you able to understand? Also it represents mixing of a system. Okay, ma'am? So how different elements or different metals or different gases, they are mixed together. Are you able to understand, ma'am? So therefore entropy represents these values: randomness, disorderness, as well as mixing of a system. Now let us try to understand this one by taking an example. Okay, see, for example, if I say take solid, if I take liquid, and if I take gas, are you able to understand? So in the case of solid, the atoms or molecules, they are arranged in a particular fashion. ఒక పర్టికులర్ ఫ్యాషన్లో అన్నీ అరేంజ్ అయ్యి ఉంటాయి. ఆర్ ఏబుల్ టు అండర్స్టాండ్? Whereas what about the atoms or molecules in the case of a liquid? They are not arranged in a particular order, no? Because for example, if you take water, the molecules of water, they will be continuously in motion. Are you able to understand? Then what about gas? We cannot say anything about gas molecules. Are you able to understand? Therefore, out of them, out of a solid, liquid and a gas, which has more randomness, which has more disorderness, definitely gas, no? So therefore I say that entropy of a gas must be greater than entropy of liquid. Are you able to understand, ma? And it should be greater than entropy of a solid. So least entropy is present for the case of solid, because entropy represents what? It represents randomness and disorderness, and it represents mixing of the system. Are you able to understand? So gases have highest randomness when compared to solid state or when compared to liquid state. Are you able to understand? Okay. Similarly, for example, see here S represents entropy. S represents entropy. Clear? Similarly, if I take one more example, for example, if I convert water into ice, are you able to understand? I am converting what? I am converting water into ice. Now the entropy of the system, has it increased or decreased? Can you say? System entropy periginda taginda? Decreased. How can you say? How can you say? In the height lona, length lona, breadth lona, dentro greater. How can you say that entropy of water is greater than entropy of ice? Ela cheptaru? Because the molecules in water, they are not arranged in a particular fashion. No, it was a particular fashion. Ikkade untayi avi. Undavu kada. It means the entropy of water is definitely greater when compared to entropy of ice. All the water molecules in the ice, they will be present in a particular spot itself. Are you able to understand? So their randomness is very less. Their disorderness is also very less. Are you able to understand? So therefore I say that entropy of water is greater than entropy of ice. Are you able to understand? Clear? Then here we discuss about delta S. What is meant by delta S, ma? Delta S means what? Change in entropy. Are you able to understand? Change in entropy. Now can you say, how can I calculate a change in entropy in this condition? Ee condition lo change in entropy ela find out chestam? No, change in entropy is always written as final value minus initial value. Change antene final minus initial kada. Whatever may be the change in kinetic energy, change in momentum, change in entropy, change in enthalpy, always you have to write final value minus initial value. Clear, Nama? So therefore I can say, so the entropy of ice minus entropy of water. Are you able to understand? No? So this is the change in entropy of the system. Okay. Now can you say this value, is it a positive quantity or a negative quantity? Huh? Negative quantity. Why? Because S of ice is greater than entropy of water, Nama. This value is lesser, this value is greater. So smaller minus bigger value? Negative value or positive value? Negative value. So therefore I can say in this condition, okay ma? So here delta S, or you can write ds, is negative. Are you able to understand? Clear, no? Are you able to understand why it is negative, ma? Negative represents what? Negative then chupistundi. Negative represents that entropy of the system has reduced. Our system entropy emayipoyindi taggipoyindani chupistundi. Okay ma? So therefore negative value of delta S or ds represents what, ma? Represents entropy of system. Entropy of system has reduced. This is what I understand, no? Let us take one more example. See ma, for example, if I convert water at 100 degrees Celsius to steam at 100 degrees Celsius. Are you able to understand? Water at 100 degrees Celsius I am converting into steam at 100 degrees Celsius. Now entropy of the system, is it positive or negative? Change in entropy, is it positive or negative? Change in entropy, is it positive or negative?
Positive.
Positive. How can you say? How can you say? Entropy of water is definitely less than entropy of steam. Are you able to understand? Because this is in liquid state and this is in gaseous state. So definitely entropy of gas is greater, no? So the disorderness, the randomness of gas is greater when compared to water, when compared to liquid state. Are you able to understand? So therefore here I can say entropy of water is definitely less than entropy of steam. Okay ma? Therefore what is delta S or ds? Delta S or ds means change in entropy. Change in entropy, how should I calculate, ma? So entropy of steam minus entropy of water. This is how I have to calculate. And this value here I will get, it is positive. Okay ma? And what does positive value indicate? Positive value then chupistundi. Positive value indicates that entropy of the system has increased. This is what we understand. Are you able to understand? So make a note of that point. So therefore what I write? Therefore I write here that, so positive value of delta S or ds represents what, ma? Represents that entropy of system has, చెప్పండి, entropy of system has increased. Okay ma? This is what I understand. Are you able to understand? Now basic concept of entropy, it is clear, nama? So what is meant by entropy? How random a system is present. So what is the amount of disorderness which is present in a system? So how many elements or how many gases or how many liquids they are mixed together? That total measure is called as entropy of a system. Are you able to understand? Now let us study the factors on which entropy depends upon. Factors on which, or we can say some examples of which how we can study the entropy change. Factors on which entropy depends upon. Are you able to understand? So first factor is entropy is directly proportional to atomicity. Okay ma? Entropy is directly proportional to atomicity. Now can you say what is meant by atomicity? Atomicity means what? Chapandi. Number of molecules, number of atoms in a molecule is called as atomicity. This is called as atomicity, no ma? For example, we will take example of helium, we will take example of oxygen, and we will take example of ozone. So in this condition, what is the atomicity of helium? 1, because in this total molecule only one atom is present. What is the atomicity of oxygen? 2, because in this molecule 2 atoms are present. What is the atomicity of ozone? 3, no? because in this molecule 3 atoms are present. Are you able to understand, ma? Now out of helium, oxygen and ozone, which is having highest entropy? Ozone is having highest entropy. What is the reason? Because its atomicity is greater. So therefore I write that atomicity of ozone is greater than atomicity of oxygen is greater than atomicity of helium. This is what I can write. Okay, ma? So what is the reason for this one? That also we will write here. So reason why if atomicity increases, entropy also increases. Okay. Reason is that, okay, as atomicity increases, okay, ma, number of bonds will increase, no, ma? Number of bonds will increase. Clear? Bonds are elastic. What is the nature of bonds, ma? Bonds are always elastic. Are you able to understand? So continuously they will be elongating and compressing. Are you able to understand, ma? So if atomicity increases, number of bonds will increase, no? Okay, ma? And what is the nature of bonds? Bonds are always elastic. For example, if you take this oxygen molecule, so there will be a bond between them, no, ma? Are you able to understand? So these bonds continuously they will be vibrating about their mean position. It means that the randomness of the system has increased, no? So as the number of bonds increases, entropy of the system also increases. And number of bonds depends on atomicity. Are you able to understand, no? So therefore if atomicity increases, entropy also increases. Clear? Okay. So here I will write one case, ma. Case is that if atomicity of elements is equal, then what is the condition? If atomicity, if it is equal, then entropy depends on what? Entropy depends on, okay, ma, molecular weight. Entropy depends on what, ma? It depends on molecular weight. Okay. So in this condition I can write entropy is directly proportional to molecular weight. Okay. So this is satisfied in which condition, ma? This is satisfied only when atomicity of elements if it is equal. Okay. For example, what is the example I can take? Let us take halogen elements. Clear, ma? So fluorine, chlorine, bromine, iodine. So all the atomicity of all of them is how much? Atomicity is 2, no? Then what about the entropy of them? Entropy of fluorine is greater, entropy of chlorine is greater, or entropy of bromine is greater? Bromine. How can you say? Molecular weight of bromine is bigger, no? Molecular weight of chlorine is bigger than fluorine. Okay. So therefore I can say that molecular weight of bromine is the highest. Okay. Therefore what I can say? Therefore I can say entropy of bromine is greater than entropy of chlorine is greater than entropy of fluorine. Are you able to understand? So this is one factor on which entropy of the system depends upon. So what is the first factor, ma? First factor is atomicity. And if atomicity is equal, then I have to check for molecular weight. So the atom which is having highest molecular weight, it will have highest entropy. That's it. Clear, no? Okay. So the next factor which I study is, I will study in the case of a chemical reaction. Okay, ma? In the case of a chemical reaction. Okay. So delta Ng, if it is positive, then, clear, ma? Delta S is also positive. Okay. Delta Ng, if it is negative, delta S is also negative. Okay. So in the case of chemical reaction, we know what is meant by delta Ng, no, ma? The change of number of moles in the case of gaseous condition in a chemical reaction is called as a delta Ng. Okay. So if delta Ng is positive, then delta S is also positive. Delta S is positive means what? Entropy, is it increasing or decreasing? Entropy increases. Clear number? Similarly, for delta Ng, if it is negative, then entropy also will be negative. Are you able to understand? Now let us see one example of what is meant by delta Ng. So delta Ng, how can I write? See here, I will write down. Delta Ng can be written as, clear? So number of moles, or I can write gaseous moles. Number of gaseous moles of products minus number of gaseous moles of reactants. Okay, ma? This factor is called as delta Ng. Okay, so how many gaseous moles are present in the case of products minus of number of gaseous moles of reactants. So this is subtraction. If you do, then I will get delta H. Are you able to understand? Let us take one example. Example is 4 moles of A gas plus 5 moles of B gas. They react to give 6 moles of C gas plus 3 moles of D gas. Let us consider this is the equation. Okay. So A and B are what? They are gaseous molecules only, no? And they are reactants. Okay. And C and D, they are what? They are also in gaseous form, but they are the products here. Now what is meant by 4 and what is meant by 5? I can say 4 atoms, or I can say 4 moles also. No? Similarly, 5 is 5 atoms are 5 moles, 6 moles, 3 moles. Are you able to understand? Now according to this relation, can you say how can I calculate a delta Ng? Delta Ng, how can I calculate? Number of gaseous moles of products. So this is the product, no? So how many number of moles are there totally? 6 plus 3, no? Minus of, what are the number of gaseous moles in the case of reactants? 5 plus 4. 5 plus 4. So totally how much, ma? 6 plus 3 is 9, minus 9 is how much? 0. Okay. So there is no change in the case of delta Ng. Delta Ng is 0. So therefore in this condition I can say that delta S is also 0. There will not be any change in entropy. Are you able to understand? So if delta Ng is 0, I can say delta S is also 0. If delta Ng is positive, delta S is also positive. Delta Ng is negative, then delta S is also negative. Are you able to understand? So delta Ng will become positive in which condition? Delta Ng positive eppudu avutundi cheppandi. Delta Ng will become positive in which condition? When number of moles of products is greater than number of moles of reactants. Then delta Ng will become positive. Okay, ma? It means number of moles are increasing, no? After the chemical reaction, number of moles, what is happening? Number of moles are increasing. If number of moles are increasing, then randomness of the system increases, disorderness of the system also increases. So automatically entropy also increases. That is the reason. Reason you did not remember, just remember this one. Are you able to understand, ma? If delta Ng is positive, delta S is also positive. If it is 0, delta S is also 0. It means there is no change in entropy in this condition. Are you able to understand? This is another factor which you should remember. Okay, ma? The next factor is, okay, third one we will write, entropy of allotropes is greater than entropy of pure metals. Okay, ma? Or you can write entropy of pure elements also. Are you able to understand? See, ma, for the same element, we have many allotropes are possible, no? For the same element, many allotropes will be possible. For example, you should have studied in carbon chemistry, no? Organic chemistry. Carbon has many allotropes. Are you able to understand, ma? So, in the case of allotropes, the entropy automatically increases when compared to original element or original metal. Are you able to understand, ma? This is another factor. Similarly, for example, if I take a boiled egg, okay? If I take an egg and if I boil this egg, entropy will it increase or decrease? ఒక గుడ్డును తీసుకొని ఉడకబెట్టినాం అనుకోండి, ఎంట్రోపీ పెరుగుతుందో తగ్గుతుందో? Decrease. How can you say? But here when you boil egg, entropy increases. This is one exception which you should remember. Okay, ma? If you are boiling egg, what is happening is the complex proteins which are present in the egg, they are split into many simple proteins. ఒక ప్రోటీన్ 10 ప్రోటీన్లుగా స్ప్లిట్ అవుతుంది అనమాట. ఇట్ మీన్స్ నంబర్ ఆఫ్ ప్రోటీన్స్ ఆర్ ఇంక్రీజింగ్, నో? నంబర్ ఆఫ్ ప్రోటీన్స్ విల్ increase. Automatically randomness, disorderness of the system will increase. Are you able to understand, ma? So in this condition, what happens when egg is boiled? Okay, ma? Complex proteins break down. Okay, and entropy increases. Entropy of the system increases. This is one point which you should remember. Clear now? Similarly, some more examples can be given in the exam. Rusting of iron. So on iron, rusting will take place now, oxidation process. Okay. So here also what happens, ma? Delta S will be positive. Delta S is positive means what? Entropy of the system increases. Are you able to understand? Similarly, if I take some more examples like crystallization of sugar, all this I think you can understand. So crystallization of sugar solution, or just a crystallization of sugar. Can you say what happens, ma? We have sugar in the form of liquid. Are you able to understand, ma? After some time it has converted into solid form. So entropy of the system, will it increase or decrease? Entropy decreases because it is converting from liquid form to solid form, nama? So solid entropy is definitely lesser. Are you able to understand? So here change in entropy is what? Negative. It means entropy decreases. Liquid form lo nunchi solid form loki convert ayinappudu emoutundi? Entropy తగ్గిపోతుంది కదా. Disorderness of the system reduces. Disorderness or randomness, if it reduces, it means entropy also reduces. Are you able to understand? Just like water converting into ice. Water is in liquid form, no? Ice is in solid form. There entropy reduces, no? Here also entropy reduces, that's all. Are you able to understand? Let us take one more example. For example, adsorption of gas. Adsorption of gas. It is not absorption. I am discussing about adsorption. Adsorption means what? Sima, this is a metal surface. So in the atmosphere, many water molecules are present. H2O molecules are present. After some time, all these H2O molecules, they get deposited on the surface of this metal. Okay? Water vapor untundi kada manaku. ఆ వాటర్ వేపర్ అంతా మెటల్ సర్ఫేస్ పైన సెటిల్ అయింది అనుకోండి. ఆర్ ఏబుల్ టు అండర్స్టాండ్? నౌ ఇన్ దిస్ కండిషన్ ఎంట్రోపీ ఆఫ్ దిస్ సిస్టమ్ హ్యాస్ ఇంక్రీస్డ్ ఆర్ డిక్రీస్డ్? Entropy, has it increased or decreased? Decreased. How can you say? Gas to liquid form it has converted, no? When all the water molecules, when they were present in atmosphere, then randomness will be greater. Now when they settle on the surface, now they are converted into liquid form, no? చూసింటారు కదా మీరు, కూల్ డ్రింక్ బాటిల్ చల్లగా ఉండేది టేబుల్ పైన పెడితే మొత్తము వాటర్ అంతా వచ్చి దానిపైన సెటిల్ అవుతుంది. మన జయంతి ఏమనుకుంటారంటే లోపల ఉండే కూల్ డ్రింకే బయటకు వచ్చింది అనుకుంటుంది అనమాట. యాక్చువల్లీ దట్ ఈస్ నాట్ హ్యాపెనింగ్. ద వాటర్ మాలిక్యూల్స్ విచ్ ఆర్ ప్రెసెంట్ ఇన్ ద అట్మాస్ఫియర్, దే గో అండ్ సెటిల్ ఆన్ ద surface of the water bottle. Are you able to understand, no? So this process is called what? Adsorption. So previously gas molecules, they were in gaseous form. Now they have converted into liquid form. Are you able to understand, no? So therefore in this condition what happens to delta S? Delta S is negative. It means entropy of the system has reduced. Are you able to understand? So like these of examples can be given in the examination. Okay, you have to identify whether randomness, disorderness, mixing of the system, has it increased or decreased. Based on that you can answer any type of question. Are you able to understand? That's it. Make a note up to here. Okay, ma'am? Now let us write the equation of entropy. What is the basic equation of entropy? We will try to understand. Completed up to here? Okay. Now see. See ma, listen very carefully. Equation of entropy. See ma, this is a system. Okay ma? In this system, some gas is present. Okay? And let the temperature of this one is T1. Okay ma? And this is the surroundings. Okay? So this is the system and this is the surroundings. System plus surroundings is called what? Universe. System plus surroundings, you can call it as universe. Are you able to understand ma? And the temperature of the surroundings is T2. So if T2 is greater than T1 and walls are diathermic, then can you say what will happen? Okay ma? Temperature of the surroundings is greater than temperature of the system. And what are the walls of the system made up of? Walls of the system are diathermic walls. What is meant by diathermic walls ma? Change in temperature. Inka? Correct?
Don't exchange.
No?
Exchange.
Exchange of heat energy, temperature. Exchange of heat energy can happen. Such type of walls, they are called as diathermic walls. Opposite of diathermic walls? Adiabatic walls. Adiabatic walls cannot exchange heat energy. So diathermic walls means they can transfer heat energy from the system to the surroundings and from surroundings to system. Are you able to understand now? Now in this condition what happens? Heat energy flows from where to where? From surroundings to system. This is what will happen now. When walls are diathermic, heat energy enters from surroundings into the system. Okay. So let Q amount of energy has entered. Enta energy enter in the from the surroundings to the system, Q amount of energy has entered. Are you able to understand? Therefore, in this condition, okay ma? So are you able to understand what is happening? So T2 is the temperature of the surroundings, T1 is the temperature of the system. T2 is greater than T1, then heat energy enters from surroundings to the system. Are you able to understand? Then ds, change in ds means what? Change in entropy of the system. Which is the system here? This one is called the system. No? So change in entropy of the system is how much ma? Amount of heat energy received by the system. In which process? In reversible process, divided by time, divided by temperature. Are you able to understand ma? See ma, what is meant by reversible process and irreversible process already we have studied no? In the reversible process, pressure is not a constant, pressure is a variable. Are you able to understand? That is called as a reversible process. And this equation is satisfied only in the case of reversible process. In irreversible process, this is not satisfied. Are you able to understand ma? So make a note of that point. Note is that above equation is satisfied only in which process? Only in reversible process. Are you able to understand ma? Similarly, now can you say what is the change in entropy of surroundings ma? Change in entropy of surroundings will be how much, can you say? Change in entropy of system we have written, no? Change in entropy of surroundings, it will be equal to minus Q reversible divided by T. This is the equation. Why I have written minus Q ma? Because surroundings are losing heat energy, no? Surroundings are losing heat energy. When it loses heat energy, what happens to its entropy? Entropy decreases. Okay ma? System is gaining heat energy. If system gains heat energy, what happens to its entropy? Entropy increases. Are you able to understand ma? Oka system ne meer heat chesnaru anukondi. If you start heating a system, what happens to the speed of the molecules in that system? Speed of the molecules increases, no? It means randomness, disorderedness also will increase. So the system, if it is receiving heat energy, its entropy increases. Surroundings is losing heat energy, no? Its entropy decreases. That is why we have written negative symbol here. Are you able to understand ma? So here one more note point you can write down. So ds in the case of irreversible process will be greater than Q in the case of irreversible process divided by time taken. Okay, ma? It means in the case of irreversible process, equation I cannot write here. I have to write a greater than symbol. Okay? So these equations are satisfied in which condition, ma? They are satisfied only in the case of reversible process. Are you able to understand? That's it. So see, ma, Q reversible divided by temperature. If heat energy increases, automatically randomness, velocity of the particles increases. వాటర్ని హీట్ చేస్తున్నారు అనుకోండి, వాటర్ మాలిక్యూల్స్ ఎక్కువ స్పీడ్తో ట్రావెల్ అవ్వడం స్టార్ట్ చేస్తాం. ఎక్కువ స్పీడ్తో ట్రావెల్ అయినాయంటే మీనింగ్ ఏమి? వాటి డిజార్డర్నెస్, ర్యాండమ్నెస్ పెరిగినాయని అర్థం. ఆర్ ఏబుల్ టు అండర్స్టాండ్? దట్స్ ఇట్. ఓకే, సో దట్ ఈస్ అబౌట్ ద ఈక్వేషన్ ఆఫ్ ఎంట్రోపీ. ఓకే, come on, make a note up to here. The processes, no, we have studied about isothermal process, adiabatic process, clear, no, isochoric process, similarly cyclic process, reversible, irreversible, all we have studied. So in all those processes we will try to understand how this entropy change will take place. Clear, no? Now let us see. So the first process which we are studying is cyclic process. Now can you say what is meant by cyclic process? Cyclic process means what? Can you say? If system is able to return to its initial states, then such process is called what? Such process is called cyclic process. Are you able to understand, ma? So for example, let us see. So this is pressure and this is volume, PV graph. So initially a gas has undergone this type of process. So here what are the initial states? P1 and V1. Okay, and temperature also we will take. So let the temperature be T1. So a process is undergone here and the gas has reached to some final state. At the final state, pressure is P2, volume is V2, temperature is T2. Are you able to understand? Now by you doing some another process, if I am able to return to the original states, then such process is called as cyclic process. Are there the cyclic process? So first from P1 V1 to T1 I have reached to P2 V2 T2 by doing some process. By doing some another process, if I am able to return to the original states, it means nothing has changed. No? After this total process, nothing has changed. Okay, so if nothing has changed, then I can say delta S will be 0. Change in entropy will be how much? 0. Because this is what kind of process? Cyclic process. There is no change in entropy. Are you able to understand? So this is the first process. Second process is adiabatic process. Okay. So what is meant by adiabatic process, ma? Adiabatic process is Q is equal to 0. Heat energy cannot enter into the system. Heat energy cannot go out of the system. Such process is called adiabatic process. Already chadukunnam kada thermodynamics lo. Clear, no, ma? So adiabatic process means what? Heat energy cannot be exchanged. Heat energy cannot be exchanged. Such process is called as adiabatic process. So therefore Q value is how much? 0. Heat cannot enter into the system. Heat cannot go out of the system also. Are you able to understand? Okay, ma? So therefore what I write? Therefore I will write delta S is equals to Q reversible divided by time. Okay, Q reversible is how much? 0. 0 by time is how much? 0. So therefore there is no change of entropy in the case of cyclic process also. Similarly in the case of adiabatic process also. Are you able to understand? Next process. Next process is isothermal process. Okay. Now from here we should be very careful, ma, how to calculate entropy in the case of isothermal process. Okay. Isothermal means, iso means same. Iso ante iso din akadani kada yo. Iso means same ikkada. Thermal means what? Temperature. So temperature is a constant, no, ma? So I can say temperature is a constant. That is called as isothermal process. Or you can say change in temperature is 0. That is also isothermal process. No? There is no change in temperature. Are you able to understand? Now if I write the first law of thermodynamics, okay ma? First law of thermodynamics according to chemistry, then I have to write delta U is equals to Q plus delta W, no ma? This is the first law of thermodynamics according to chemistry, no? Clear, no? Delta U is equals to Q plus delta W. Now if a temperature is not changing, then I can write delta U will never change. Okay. What is delta U? Change in internal energy. Already we studied in thermodynamics, no? What we have studied? Internal energy depends only on temperature. Temperature perigindante edi periginatlu? Internal energy periginatlu. Temperature is not changing, no? So internal energy also does not change. Are you able to understand, ma? So therefore what I write? As temperature remains constant, okay ma? There is no change. There is no change in what? There is no change in internal energy. So delta U is 0. It reveals that a change in internal energy is 0. Internal energy 0 అని కదా U. అట్లా అనుకుంటారు మళ్ళీ. Are you able to understand, ma? Internal energy is remaining constant. Change in internal energy is not there. So change in internal energy is 0. Understood, no? Therefore I can write 0 is equals to Q plus W or Q plus delta W. I can write like this, no? So therefore heat supplied is nothing but negative of work done. In which process? In the case of isothermal process. Okay. And in thermodynamics already we have studied what is the amount of work done in the case of isothermal process. Do you remember? Oh no. Okay, nene rasta. So Q is equals to negative of work done in isothermal process is how much, ma? So minus 2.303 nRT log V2 divided by V1. This is the equation. Okay, ma? So minus of minus will become plus. Or you can write minus of minus 2.303 nRT log P1 divided by P2. Like this also you can write. Okay, ma? Because in the case of isothermal process, PV is a constant. It means pressure is inversely proportional to volume. Okay. So V2 by V1 can also be written as P1 by P2 also. So I can write like this also. Are you able to understand? So therefore, now substitute in the equation of entropy, ma? So therefore what is entropy? So delta S in the case of isothermal process is how much? It is Q reversible divided by temperature. So Q reversible is how much? So minus of minus will become plus, no ma? So 2.303 nRT log V2 divided by V1 divided by temperature. Clear, no? So T and T, if it gets cancelled, so delta S is equal to ds is equals to how much? 2.303 nR log V2 divided by V1, or also you can write 2.303 nR log P1 divided by P2. Clear, no? So this is the equation of a change in entropy in which process, ma? In the process of isothermal process. Are you able to understand? Equation of change in entropy in the case of which process? Isothermal process. Understood, no? Next one, fourth one. We will study about isobaric process. Isobaric process. Are you able to understand? What is meant by isobaric process, ma? Pressure is a bar means the unit of measuring pressure. Isobaric means same pressure. Okay. So here I can write pressure is a constant, or I can write delta P is how much? 0. Change in pressure is not there. Okay, ma? So in the case of isobaric process, the amount of heat energy which you supply can be written as NCP delta T. I can write like this. Are you able to understand? In the case of isobaric process, pressure is a constant, no? So specific heat of the gas will be how much? Specific heat of the gas will be Cp, or heating the gas at constant pressure. Okay, ma? What is meant by specific heat? Already we have studied, no, ma? Q divided by N delta T is called as specific heat. The amount of heat energy supplied to rise the temperature of 1 mole of a gas by 1 degree rise in temperature is called as specific heat. We are heating the gas in which process? Isobaric process. So specific heat will be Cp, specific heat at constant pressure. Are you able to understand? So therefore Q can be written as NCP delta T, no? Are you able to understand? Now let us write down. So therefore what I can write? Therefore, okay, ma? So ds in the case of isobaric process, how I can write? I can write Q reversible divided by time taken, okay, ma? Or you can write NCP dt divided by T. This is how I can write. So I am writing ds, no? So change in temperature also I will write dt. Small change in entropy because of small change in temperature. Are you able to understand? Now integrating on both sides. Integrating on both sides. Are you able to understand, ma? So if I integrate, integration of ds in the case of isobaric process is equals to integration of NCP dt divided by T. This is what I can write. ds is what, ma? Small change in entropy. Integration of ds, total change in entropy. Integration is a process of addition, no? Integration ante mani basically addition, add cheyadamu ani. So small change converts into total change. So I can write delta S in the case of isobaric process is equals to, clear, ma? So N and Cp, they are constants, no, ma? Take them out of integration. So integration of 1 by T dt. Okay. So integration of 1 by T dt is how much? It is a natural logarithm of T, and limits are applied from T1 to T2. So here also I will apply the limits from T1 to T2. So integration means limits of integration also should be there, no? So initial temperature is T1, final temperature is T2. So change in temperature T2 minus T1. Okay, ma? So therefore the change in entropy in the case of isobaric process is how much, ma? I can write it is NCP log T2 divided by T1. This is how I can write. Okay. First of all, I have to substitute upper limit, no, log T2. Then I have to substitute the lower limit minus log T1. So log T2 minus log T1 will be how much? Log T2 by T1. You know this rule, no, ma? So log x minus log y is how much? Log x by y. So by using same rule, we have written this. Are you able to understand? Now here I have written ln. Ln means what? Natural logarithm. Natural logarithm means to the base of e. But if I want to convert this one as base of 10, then what I have to do? If I want to convert this logarithm to the base of 10, then I have to multiply by 2.303. Arthamautundi kada? So therefore, change in entropy in the case of isobaric process is how much? 2.303 NCP log T2 divided by T1. This is the equation. So this is the change in entropy in the case of isobaric process. Are you able to understand, ma? Why I have written 2.303 understood, no? Here it is natural logarithm. A natural logarithm means what? Ln can be written as log to the base e. This is how I can write. But I have converted this one to the base of 10, log to the base of 10. Then I have to multiply by 2.303. That's it. Clear, no? Okay. Similarly, the next process is called Isochoric process. Okay, ma? What is meant by Isochoric process? Volume is a constant. So volume of a gas is a constant. It means a change in volume is how much, ma? Change in volume is 0. There is no change in volume. Volume remains a constant. Okay. So when you are heating the gas at a constant volume, the total heat energy which you supply converts into internal energy of the gas. Thermodynamics lo chadukunnam gurtunda? Clear, ma? When you are heating the gas at a constant volume, మీరు సప్లై చేసే మొత్తం ఎనర్జీ ఏమవుతుంది? The total energy which you supply converts into internal energy of the gas. Okay. So therefore here I can write Q is equals to NCV delta T. In isobaric process what we have written? Q is equal to NCP delta T, heating the gas at constant pressure. But we are heating the gas at constant volume, no? So instead of Cp, I will write Cv, NCV delta T. Okay. So therefore, again doing the same type of process. Okay. Now, no need of doing once again, no? So here I will write same as calculation, same as isobaric process. What is the final equation I got? Same equation I will write here also. So delta S in the case of isochoric process is how much, ma'am? 2.303 N instead of Cp, NCV log to the base 10 T2 divided by T1. That's all. That is my equation of change in entropy in the case of isochoric process. Are you able to understand? Only ఇదే ప్రాసెస్ 14 సార్లు రాయడం ఎందుకు, మీరే రాసుకోండి. These calculations are not required, just for your understanding. These values you are supposed to remember. Equations you should remember. Understood, Nama? So these are the different equations of entropy in different processes. Okay? So all these equations you must remember very carefully. So in the case of cyclic process, change in entropy is not there, 0. In the case of adiabatic process, change in entropy is not there, again 0. In the case of isothermal process, 2.303 nr log V2 by V1 or P1 by P2. In the case of isobaric process, it is 2.303 NCP log T2 divided by T1. In the case of isochoric process, 2.303 NCV log to the base 10 T2 divided by T1. That's all. These are the equations which you should remember. Are you able to understand? Your pedlu alade. Okay. So in the last class we have studied about different equations for change of entropy, norma. So some more conditions we are studying, like what is the change of entropy in the case of different process in the case of ideal gas. Are you able to understand, no? So first of all, let us take this process now. What is P1 V1? This is called initial state, no? P1 V1 is called as initial state of the gas. Then we are moving to P2 V2, which is called as final state of the gas. So in moving from P1 V1 to P2 V2, what is the change in entropy I want to calculate. Are you able to understand? See, but directly in moving from P1 V1 to P2 V2, instead of moving directly, I can write in steps also, no? Are you able to understand, no? I can write in steps. So what is the first step? I can write P1 V2, I can write like this. Then from here again I will move to P2 V2. Are you able to understand, no? So this is the first process where pressure is remaining constant, no? So here also P1, here also P1. So pressure is remaining a constant. But what about volume? Volume is changing. So can you say this is what kind of process? Pressure is constant, no? So here pressure is a constant. So definitely I can say this is a isobaric process. Are you able to understand? So here change in entropy will be delta S in the case of isobaric process. Clear? Then I am moving from P1 V2 to P2 V2. So in this condition volume is constant, no? Pressure is changing from P1 to P2, but volume is a constant. So this one I can call it as a isochoric process. Are you able to understand, no? This is an isochoric process. So here what is the change of entropy? Delta S in the case of isochoric process. Okay. And change in entropy in isobaric process, change in entropy in isochoric process. Yesterday we have written the equations. So write the same equations here. So total change in entropy is how much? It is equal to change in entropy in the case of isobaric process plus change in entropy in the case of isochoric process. Are you able to understand? So in the case of isobaric process, what is the formula for change in entropy, ma? It is 2.303 isobaric, no? So NCP log to the base 10, so T2 divided by T1. This is the equation. Are you able to understand? This was the equation which we derived yesterday, no? Similarly, what is the change in entropy in the case of isochoric process? Just instead of NCP I have to write NCV, that's all. Therefore 2.303 NCV log to the base 10 T2 divided by T1. This is the equation. This is how I can write. So if any process is given, Manoj tvarga ravali. Okay, clear now? So if this is the process which is happening, then definitely I can write in steps and I can add the total entropy. Are you able to understand now? So my entropy, how I am able to add like this, can you say? I am just adding like 1 plus 2 is 3, no? I am just adding 1 plus 2 is equal to 3, algebraic form. How can I add like this? Because already we have studied that entropy is a state function. Already we studied, no ma? Entropy is what kind of function, ma? It is a state function. So it depends only on initial position and final position. It doesn't depend upon the path in which we are moving. What are the path functions? Path function saving. Heat supplied is a path function. Are you able to understand, ma? Work done is a path function, but entropy is a point function. It depends only on initial point function only, no? State function, or you can write just it is a point function. Point function means what? It depends only on initial point and final point. Are you able to understand? So whatever may be the process I will do, change in entropy definitely I can say the change in entropy in first condition and change in entropy in second condition. Definitely I can write like this. Clear, ma? Similarly, if I write one more example, so let us consider I want to change the gas from T1 V1 to T2 V2. So in this condition, can you calculate the total change in entropy? Calculate cheyandi. Clear, no ma? So what is T1 V1, ma? Initial state of the gas. Initial temperature is T1, initial volume is V. And what is the final state of the gas? Final temperature is T2, final volume is V2. Now in this total process, what is the change in entropy? How can I calculate? Again I can travel in steps, no? How can I travel in steps? So first I travel like this, then I go like this. Are you able to understand, ma? So let us consider this is a T1 V2 and finally I am moving from T1 V2 to T2 V2. Okay. Now in traveling from here to here, this is what kind of process, ma? Temperature is constant, no? So here what is constant? Temperature is a constant. Temperature is a constant means this is isothermal process. Okay, ma? Therefore what is the change in entropy? Delta S in the case of isothermal process. Are you able to understand? Now in moving from T1 V2 to T2 V2, this is what kind of process? Volume is remaining constant, no? So this is a isochoric process. Are you able to understand, ma? What is constant here? Volume is a constant. So what is the change in entropy? Delta S in the case of isochoric process. That's all, ma? Therefore what is the total change in entropy? Chapandi, silent untarema. Total change in entropy is how much? Change in entropy in the case of isothermal process plus change in entropy in the case of isochoric process. That's all, ma? And this formula already we have written, no? So what is the change in entropy in the case of isothermal process? 2.303 NR log V2 divided by V1, or you can write P1 divided by P2 also. Are you able to understand? And what is the change in entropy in the case of isochoric process, ma? 2.303 NCV log T2 divided by T1. Okay, that is the total change in entropy. Are you able to understand, ma, how we are doing? So in this method, very easily you can calculate the total change in entropy, whatever may be the state functions are given. Yes, state function aina ila meer cheyochu. Okay, that's it. Make a note up to here. నువ్వు ప్రతిరోజు 5 నిమిషాలు లేట్గా ఎందుకు వస్తావో చెప్పంటావురా నేను? చెప్పాలి. ఊరికి అడిగినాను వద్దన్నా చెప్తా, ఊరికి అడిగినా చెప్పాలన్నా వద్దా? ఎందుకంటే ట్రైన్ పేరు పెట్టుకున్నావు కదా, భారతదేశంలో ట్రైన్లు పొరపాటున కూడా టైంకి రావన్నమాట. ఆ ట్రెండ్ను అలా ఫాలో అవుతా ఉన్నావు. Okay, same. So next application which we are studying is change of entropy in the case of phase changes. What is meant by phase change, ma? Water converting into ice converting into steam. This is called phase change, no? State is changing. State doesn't mean Tamil Nadu, Andhra Pradesh, Karnataka, liquid state to solid state to gaseous state. Are you able to understand? See, ma, when phase is changing, in physics you should have studied, no, in heat topic. When phase changes, what are the changes which happens? Temperature never changes. For example, if you take 1 kg of ice and if you want to melt 1 kg of ice, then you have to supply heat energy, no? 1 kg ice ni melt cheyalante mere heat energy ni supply cheyali. So until total 1 kg of ice converts into water at 0, temperature of water will not increase. Ice మొత్తం మెల్ట్ అయిన తర్వాతే టెంపరేచర్ పెరుగుతుంది. Are you able to understand? So the total heat energy which you supply will be utilized for what? Only changing the phase of that particular material. Are you able to understand ma? Temperature never changes in phase transformations. Phase transformations lo temperature maradu. Are you able to understand? That is why that heat which you supply is called latent heat in physics. Latent heat means what? Hidden heat. మీరు ఐస్ని హీట్ చేస్తూ ఉంటారు, టెంపరేచర్ మాత్రం పెరగదు. ఏమైంది తల కొక్కుంటూ ఉంటారు మీరు. అర్థమవుతుంది కదమ్మా? కంటిన్యూస్లీ యూ ఆర్ సప్లైంగ్ హీట్ ఎనర్జీ బట్ టెంపరేచర్ నెవర్ చేంజెస్ అండ్ యూ కెన్ నెవర్ అండర్స్టాండ్ వాట్ ఈస్ హ్యాపెనింగ్. వాట్ ఈస్ హ్యాపెనింగ్? దట్ టోటల్ హీట్ ఎనర్జీ ఈస్ యూటిలైజ్డ్ ఫర్ చేంజింగ్ ద phase of the substance from solid state to liquid state and from liquid state to gaseous state. So temperature never changes in phase transformations and system is always in equilibrium. What is meant by system is in equilibrium? System is in equilibrium means concentration of products and concentration of reactants is a constant. It never changes. Okay ma? For example, if you are heating water, concentration of water, will it change? It never changes. For example, if you are melting ice, concentration of ice, will it change? It never changes. So system is always in equilibrium. So another point is total heat supplied is nothing but a change in enthalpy. Are you able to understand ma? What is meant by enthalpy? Enthalpy is nothing but the total amount of internal energy the system possesses plus the product of pressure and volume. This is called as enthalpy of a system. Are you able to understand ma? This we will discuss later. Now just for your information I am writing here. Are you able to understand? So therefore total heat supplied is nothing but total change in enthalpy. I can write a delta H. So this is always satisfied in the case of phase changes. Are you able to understand ma? And total heat which you supply, it is always utilized for changing the phase only. Temperature never changes. Ee points anni meeru gurtu pettukovali in phase transformations. Are you able to understand ma? Temperature never changes. Total heat supplied is nothing but total change in enthalpy and only state changes, temperature does not change. Okay. So in phase transformations I can study about two types of transformations. Nama? So one is entropy of what you call fusion and entropy of vaporization, both we can study. Okay. So first of all we will study entropy of fusion or you can also call it as melting also. Okay. So what is meant by fusion? Solid converting into liquid or also you can say liquid converting into solid. This is called as fusion. Are you able to understand? So therefore here how can I write delta S in the case of fusion can be written as Q divided by T. Q is heat supplied, no ma? Heat supplied in the case of fusion. So heat supplied in the case of fusion can also be written as change in enthalpy in the case of fusion divided by temperature of melting. So I can write like this. Are you able to understand now? So what is the change which we are doing? This is the formula of entropy, no? Q divided by temperature. Instead of Q, what I am writing? Change in enthalpy, that's all. Change in enthalpy divided by which temperature? See ma, phase transformations always happen at a particular temperature and that temperature is called as temperature of melting. Are you able to understand? For example, if you take ice, ice starts converting into water at which temperature? Only 0 degrees Celsius. Are you able to understand? 0 దగ్గర మాత్రమే ఐస్ వాటర్గా కన్వర్ట్ అవుతుంది. వేరే టెంపరేచర్ దగ్గర ఎక్కడ కూడా పాసిబుల్ అవ్వదు. దట్ ఈస్ ఆల్రెడీ వీ హ్యావ్ రిటన్ టెంపరేచర్ ఈజ్ ఏ కాన్స్టెంట్. ఆర్ ఏబుల్ టు అండర్స్టాండ్ మా? సిమిలర్లీ ఐ విల్ రైట్ ఎంట్రోపీ ఆఫ్ vaporization and here temperature of melting if it is water you can write 0 degrees Celsius or in Kelvin you can write 273 Kelvin also. Are you able to understand ma? So you better write that case also. Okay, case is what? If water is taken then change in entropy in the case of fusion, how can I write ma? So change in enthalpy in the case of fusion divided by 273 Kelvin. So you can write like this also. 0 degree Celsius is also called 273 Kelvin no ma? ఇలా మీరు రాసుకోవచ్చు. అర్థమవుతుంది కదా? Or you can write 0 degree Celsius is how much? 273 Kelvin. You can write like this. Okay ma? Next, what is the next phase transformation which is possible ma? So here I can say what ice is converting into water. Then if you start heating water, now water at 100 It converts into steam at 100, no? 100 అంటే 100 km/h అని కాదు, 100 degrees Celsius. Are able to understand, no? So second application is change in entropy. In which condition? In vaporization. Are able to understand? So therefore again similarly how can you write? So first of all, what is meant by vaporization, ma? Liquid form it converts into steam or vapor form, or steam converts into liquid. Both of them you can call them as change in entropy in the case of vaporization. Are able to understand, ma? For example, water converting into steam, steam condensing into water. Both are taking place at a constant temperature of 100 degrees Celsius. Are able to understand? Therefore again similarly how can you write, ma? Delta S vaporization is equals to Q vaporization, heat energy supplied in vaporization, divided by temperature of boiling. That temperature is called boiling temperature only, no, ma? What is meant by boiling temperature? Temperature at which liquid converts into gas, that is called as boiling temperature. Are you able to understand? So again I can write a change in enthalpy in the case of vaporization divided by temperature of boiling. Okay, ma? And case you can write. Case is what? If water is taken. Okay, ma? If water is taken. If you take water, then what is the temperature of boiling, ma? Temperature of boiling 100 degrees Celsius. In Kelvin you can write 373 Kelvin. So substitute those values. So delta S in the case of vaporization is how much you can write? Delta H of vaporization divided by 373 Kelvin. So you can write like this also. Are you able to understand? ఏమీ లేదు ఇక్కడ విషయం, శూన్యం అంతా. జస్ట్ కండిషన్స్ కేసెస్ రాసుకుంటూ పోతాను, దరిద్రం అంటే దాంట్లోంచే క్వశ్చన్లు వస్తాయి, అంతకు మించి ఏం లేదు. క్లియర్ మా? దట్స్ ఇట్. ఓకే, దెన్ we study. Okay, for example if I write one more application, ma, third one, entropy in or change in entropy in sublimation. Change in entropy in the case of sublimation. Now can you say what is meant by sublimation, ma? Sublimation means what? Solid directly converting into gas bypassing the liquid phase. For example, you know camphor తెలుసు కదా, తెలుగులో ఏమంటారు దాన్ని? కర్పూరం. సో ఇఫ్ యూ ప్లేస్ ఇట్ ఇన్ ఎయిర్, ఇట్ డజంట్ కన్వర్ట్ ఇంటూ లిక్విడ్ ఫామ్, డైరెక్ట్లీ ఇట్ కన్వర్ట్స్ ఇంటూ వేపర్. ఆర్ ఏబుల్ టు అండర్స్టాండ్? సో దట్ ఈస్ కాల్డ్ యాజ్ సబ్లిమేషన్. సో దేర్ ఫోర్ హౌ ఐ కెన్ రైట్ సాలిడ్ డైరెక్ట్లీ కన్వర్టింగ్ ఇంటూ వేపర్, ఆర్ వేపర్ కండెన్సింగ్ డైరెక్ట్లీ ఇంటూ solid, that is called as sublimation. Are you able to understand, ma? So here I can write delta S in the case of sublimation is equals to Q of sublimation divided by temperature of sublimation. Reversible. So solid vapor loki మారొచ్చు, vapor direct గా solid లో కూడా condense అవ్వచ్చు. Are you able to understand, ma? So therefore this how I can write delta H sublimation divided by temperature of sublimation. Okay, ma? And entropy is a which function? Entropy is a point function. Entropy is a point function, no ma? It is not a it is not a path function. It depends only on initial point and final point. కాబట్టి మీరేం చేయొచ్చు చెప్పండి. So delta S sublimation can also be written as delta S of fusion plus delta S of vaporization. So you can write like this also. Are you able to understand? So for solid directly converting into vapor, we can consider it converts into liquid form also, no? Okay, so solid converting into liquid, delta S fusion. Liquid converting into gas, delta S vaporization. Are you able to understand, no? If you add both of them, definitely you will get this value also. Because entropy is a point function. It only depends on initial point and final point. It doesn't depend on the path taken. ఎలా ట్రావెల్ చేస్తున్నాము దానిపైన అది డిపెండ్ అవ్వదు. డిస్టెన్స్ డిస్ప్లేస్మెంట్ లాగా అనుకోండి. డిస్టెన్స్ పాత్ పైన డిపెండ్ అవుతుంది, డిస్ప్లేస్మెంట్ అదంతా పని లేదు, ఎక్కడ పోయినా చెప్పంటుంది అనమాట అలా. సో మేక్ నోట్ ఆఫ్ దిస్ వన్. ఓకే, సో నెక్స్ట్ we are studying about the change in entropy in the case of universe. So what is meant by universe already we have studied now, the system which we are studying plus the surroundings in which system is not present, that is called as surroundings. So system plus surroundings will give universe. Are you able to understand? So therefore total change in entropy in the case of universe is equals to change in entropy in the case of system plus change in entropy in the case of surroundings. Are you able to understand now? Now see. So change in entropy in the case of universe I can study in these many processes now. First of all I will study reversible process, then I will study irreversible process. And reversible process can be cyclic also, non-cyclic also. Are you able to understand? Similarly irreversible process also, it can be cyclic also, it can be non-cyclic also. Okay. So first of all let us draw some conclusions before filling this table. See now. In the case of cyclic process, change in entropy of the system is always zero, whether it is reversible process or whether it is irreversible process. Are you able to understand? If it is a cyclic process means what? Already we discussed, So first of all we travel by one process, and by second process again I reach to the same state. That is called a cyclic process. Are you able to understand? Sima. So first of all I travel from here to here. It may be adiabatic, it may be isothermal, it may be isochoric, it may be anything. Are you able to understand? So then by doing another process, again if I am able to reach to the same state, then it is called a cyclic process. So state functions change avatan ledu kada. State functions are not changing. If a state functions are not changing, entropy also doesn't change. Are you able to understand? So entropy of the system, change in entropy of the system is zero. In which process? In cyclic process. This is one point which already I discussed in the last class. Are you able to understand? Similarly, if it is irreversible process, are you able to understand? Then I can say that, so delta S or ds of the system is greater than 0, okay ma? And it is non-cyclic irreversible process. So ds of the system is greater than 0. Similarly ds of the surroundings also not greater than 0 greater than q irreversible divided by temperature, and this is also greater than q irreversible divided by temperature. This point also I have explained you yesterday only. If it is an irreversible and which process? Non-cyclic process. Okay ma? And this is satisfied for both reversible and irreversible. Are you able to understand? For whatever it may, whether it is reversible or irreversible, so change in entropy of the system will be zero. Are you able to understand? System lo entropy change undadu eppudu adi cyclic process ayinappudu, because always we are reaching to the same position. No? Are you able to understand? Now if it is irreversible and non-cyclic process, then change in entropy of the system is always greater than q reversible divided by temperature, and temperature or change in entropy of the surroundings, again it is greater than q irreversible divided by temperature. These points you should remember. Okay. Once you remember them, now let us try to fill this table. So which is the first one we are studying? Reversible cyclic process. Clear now? So because this is a cyclic process, ds of the system is how much? 0. That's what I have written now. Change in entropy of the system is 0. And this is a reversible cyclic process. So ds of the surroundings is also how much? ds of the surroundings is also 0. Okay. Then what is the total change in entropy of the universe? So it is ds of a system plus ds of surrounding. Write it very very clearly ma. So total it will be 0. Are you able to understand? So what do you understand here? We understand that in reversible cyclic process there is no change in entropy in the case of universe. Are you able to understand? But the problem is, so where shall I write? Here I will write down now. In notes you write here, but in this board I am writing here. This reversible cyclic process practically not possible. It is not practically possible. This is a theoretical process. Are you able to understand, ma? So we say that efficiency of a mission can be made 100%. Efficiency of a mission can never be 100%. Always there is some loss of energy, because energy always converts into heat energy, no? 100% energy you can never convert into work. Are you able to understand? Similarly, reversible cyclic process where these conditions are met, that is never possible. Are you able to understand? Because according to second law of thermodynamics, after any process, entropy of a system or entropy of universe always increases. That we will study later. Okay? So next item. See, my non-cyclic reversible process. So this is a reversible process, but this is what kind of process? Non-cyclic process. Are you able to understand, ma? No. So consider this is a system, okay, ma, in which gas is present, and temperature of the gas is T1. Or I will write here, temperature of the gas is how much, ma? Temperature of the gas is T1. And this is the surroundings, okay, and surroundings temperature is T2. So let us consider T2 is greater than T1. Temperature of surroundings is greater than temperature of system. Then what will happen? Then heat energy travels from surroundings to temperature. This is what happens to. And this is what kind of temperature? This is heat energy supplied in reversible process. Reversible process. This is reversible process only, no? So here heat energy is entering into the system. So this is a non-cyclic process. Non-cyclic process means delta S of the system is not zero. Is not zero. Only in cyclic process only it is zero. Non-cyclic process it is not zero, because it is not able to reach the original state, no? Non-cyclic process means what? So this is one process, this is another process. So initial states, final states, they are not same. Are you able to understand, ma? So therefore I can write change in entropy in the case of system. System means this one is how much? It is heat received in the case of reversible process divided by temperature of the system. Are you able to understand? Change in entropy, what is the formula? Q by T. Q in which process? Reversible process. Temperature of what? Temperature of the system. Satisfied now? Okay. E exceptions gurtupettukovali. Then very easily we can fill the table, and whether question is given on this table, very easily you can answer. Are you able to understand, ma? Similarly, delta S or ds of surroundings is how much, ma? It is losing heat energy, no? So minus Q reversible divided by T2. Temperature of the surroundings is T2. Are you able to understand, ma? Okay. Now see, ma. Now when you observe ds of system and ds of surroundings, which one is bigger? Magnitude wise, which one is bigger? ds of system is bigger. How can you say? Don't check for positive or negative values. Magnitude wise, already cheppinanu kada. Magnitude wise, out of change in entropy of system and change in entropy of surroundings, which one is bigger? System. How can you say? Huh? Magnitude aduguta unnaru. Magnitude. I am not asking entropy of which system is increasing, which entropy of which system is decreasing. I am not asking about that. I am asking about, you remove plus symbol and minus symbol. ఈ ప్లస్లు మైనస్లు తీసేయండి కాసేపు, ఇది ఇలా వదిలేసి. So ds of system is greater or ds of surroundings is greater? System. How can you say? That is the point which you should understand here. Okay, ma? See, ma, numerator is same, no? So surroundings anta temperature lose ayindho, system ante heat energy ni gain cheskundi. Heat energy ni gain cheskundi. So numerator is same. But T2 is greater than T1, no, ma? Okay? And temperature it is in denominator. Temperature ekkada undi? Denominator. If denominator is smaller, total value will be bigger. Ante kada? 10th taragati pass ayinaru kada. Mari cheppandi mari. Clear, ma? So 10 by 2 is bigger, 10 by 5 is bigger.
10 by 5. 10 by 5.
10 by 2 is 5. 10 by 5 is 2 only, no? So definitely this one is bigger. Why this is bigger? Because denominator is smaller. Understood, Nama? So here T1 is smaller, no? T1 is smaller. So ds of the system is bigger. But this is positive value and this is a negative value. Are you able to understand? So therefore I can say that, here I am writing the reasoning I will write here, ma. As T1 is smaller than T2, okay, ma, magnitude of ds of system is greater than magnitude of ds of surroundings. Okay. So entropy has changed by greater value of which one? System or surroundings? ds of system is greater, no, ma? So change in entropy in system is greater when compared to change in entropy of surroundings. అర్థమైంది కదా? ఇటువంటి వాటిపైన కెమిస్ట్రీలో క్వశ్చన్స్ అడిగాడు. Are you able to understand? Okay. So therefore now if I write ds of universe, it is ds of system plus ds of surroundings. Okay, ma? One value is positive, another value is negative. Positive value is bigger or negative value is bigger? Positive. ఈ వాల్యూ పెద్దగా ఉంది కదా, సో టోటల్ వాల్యూ ఆల్సో విల్ బి పాజిటివ్. ఫర్ ఎగ్జాంపుల్ I can say this is plus 10, this is minus 8. 10 is bigger, 8 is bigger? 10 is bigger. So 10 minus 8? 2. Plus 2. Are you able to understand, ma? So here also I will get ds of the universe is positive. Clear? ds of the universe is positive means what? Positive అంటే ఏమన్నా లాస్ట్ క్లాస్లో చదువుకున్నాం కదా. ds is positive means entropy is increasing. Are you able to understand, ma? So therefore in reversible non-cyclic process, so entropy of the universe finally increases. ఇది కంక్లూజన్. ఈ కంక్లూజన్ చేయడానికి సుప్రంతా చేస్తున్నాను. Are you able to understand, ma? So here what we write, finally entropy of universe increases. ఆరో సింబల్ పెట్టారంటే ఎంట్రోపీ ఆకాశానికి పోయిందని కాదు, అయ్యో పెరిగిందనేది. మీ తెలివితేటలు కొంచెం ఆలోచించండి. క్లియర్, మా? Finally we have observed that entropy of the universe has increased. That is the observation. Okay. Now let us come to irreversible cyclic process. Are you able to understand, ma? Now see. So questions can be asked on any of these parameters, ma. దేనిపైనైనా మీ క్వశ్చన్ అడగచ్చు. కేర్ఫుల్గా విని కేర్ఫుల్గా బట్టి కొట్టండి. అర్థం చేసుకునేది ఏం లేదు, బట్టి పట్టడమే అంతే. క్లియర్, మా? సో cyclic process. Clear? Now see. So cyclic means what I have written? Cyclic means what I have written, ma? Delta S of the system? 0. So write down that one. So ds of the system is 0. Are you able to understand? But surroundings is not 0.
Minus q
Here you need not write minus. So ds of surrounding is greater than q in the case of irreversible process divided by temperature. Are you able to understand, ma? So here ds of the universe, this is positive. Are you able to understand, ma? So this is positive value, this is also a positive value. If you add both of them, then also it will be positive. It means after irreversible cyclic process, again entropy increases. Are you able to understand? Here also entropy increased, here also entropy of the universe has increased. Clear, no? Entropy of the system is 0. Entropy of the surroundings is not 0. It is always greater than q irreversible divided by temperature of the surroundings. Understood, Nama? Next, coming to non-cyclic process. Are you able to understand? So this is non-cyclic process, Nama. ds of the system is not 0. ds of the system is not 0. So therefore what I can write? So ds of system is greater than q irreversible divided by t1. Understood, Nama? Similarly, ds of surroundings is equals to or greater than q Q irreversible divided by T2. Are you able to understand? And again here, if you write a negative value here, are you able to understand? Again positive value is greater than negative value. So again entropy of the universe increases. It becomes positive. Okay. So again I can write ds of universe is how much? It is positive value. Increases. Total entropy of the universe increases. So if you see all the processes, in every process, entropy of the universe has finally increased. But this case is an exception. Here entropy of the universe is 0. Abu, time हो गया ना? 7 कुछ ना भेज. Okay, so are you able to understand now? So finally what we understand Sima here, so change in entropy in the case of universe is how much? It is 0, but what we have written, this is practically not possible. This case is not possible. Are you able to understand? This is possible, this is possible, this is possible, that is also possible. So in all these cases, what about the change of entropy in the case of universe? It has increased finally. And this is exactly what is called as second law of thermodynamics. This observation name antam manamu second law of thermodynamics. So what is the statement of second law of thermodynamics? Run. So unda akkada benchu kuchu 7k class 7:45 కి వచ్చినారే మీరు? ఏ సార్? అట్లానా? ఓకే ఓకే ఓకే. సో అండర్స్టూడ్ నమ్మా? సో రైట్ ఆన్ ద స్టేట్మెంట్. ఇది రన్ అయితేనే ఉందా? ఓకేమ్మా. సో వాట్ వాస్ అవర్ ఫైనల్ అబ్జర్వేషన్? అవర్ ఫైనల్ అబ్జర్వేషన్ వాస్ దట్, so after any process, whether it is reversible or irreversible process, finally entropy of the universe has finally increased. This is exactly what is called as second law of thermodynamics. So how can we write the statement? One statement wise I can write, after any process, clear ma, entropy of universe finally increases. Are you able to understand? So this is called as second law of thermodynamics according to physics. Okay ma? Sorry, chemistry. Physics prakaram inko definition undi. Okay? Physics prakaram definition emi, efficiency of the system can never be 100%. Adi physics prakaram definition. Idi chemistry prakaram entropy peragali danlo unda. Okay. So because we have written second law of thermodynamics, we will write third law also ma. So third law of thermodynamics. Are you able to understand? So it says that at 0 degrees we should not write, 0 Kelvin, the change in entropy for a perfect crystalline substance, మాట్లాడితే పైనుంచి కిందికి వేస్తా, సెకండ్ ఫ్లోర్ నుంచి. ఓకేమా? ఎంట్రోపీ ఫర్ ఎ పర్ఫెక్ట్ క్రిస్టలైన్ సబ్స్టెన్స్ ఈజ్ 0. ఓకేమా? దిస్ ఈస్ కాల్డ్ యాజ్ ద థర్డ్ లా ఆఫ్ థర్మోడైనమిక్స్. ఆర్ ఏబుల్ టు అండర్స్టాండ్ మా? అట్ విత్ టెంపరేచర్? అట్ ఎ టెంపరేచర్ ఆఫ్ 0 Kelvin. 0 Kelvin అంటే -273.15 degree Celsius. So this is the least possible which is present in the universe, no? So less than this temperature it is not possible. ఇంతకన్నా least temperature మనకు సృష్టిలో లేదన్నమాట. Okay? So there is no limit for higher temperature. Higher temperature కి లిమిట్ లేదు. But God has created a lower limit for lower temperature and it is -273.15. So at this temperature, the total change in entropy for which kind of crystal, for which kind of substance? Perfect crystalline substance is always 0. So this is called as the third law of thermodynamics. Understood, Nama? Okay. Then one more important point we will write here, Ma. One more important point is, so change in entropy in a chemical reaction. Okay, ma? Change in entropy in the case of a chemical reaction. Are you able to understand? So here I can write the change in entropy in a chemical reaction is equals to the change in entropy in the case of products minus change in entropy in the case of reactants. Okay. So I think in NEET 2017 or 18 question was asked directly on this relation. Clear? So what is the total change of entropy in the case of reaction? Change in entropy in the case of products minus change in entropy in the case of reactants. Are you able to understand, ma? And you write one more note point. Ma. Note point is that change of entropy is always calculated per mole only. Okay, ma? Change of entropy we calculate for what? We calculate only for 1 mole of a substance only. ఒక atomకు ఒక moleculeకు define చేయవు. Are you able to understand, ma? Any calculation in chemistry, not only entropy. Almost every calculation in chemistry we always do only for the case of a single mole. Okay? And what is meant by mole? Mole అంటే చెప్పడం వరకు బాగానే ఉంది సార్. క్వశ్చన్లు అడగాకండి మమ్మల్ని. క్వశ్చన్లు అడిగితే మాత్రం చెప్పలేము మేము. అంత లెంత్ కాకుండా కొంచెం షార్ట్గా చెప్పరా. 1 mole is just the total number of 6.022 into 10 power 23 molecules or atoms or ions. This is called as 1 mole. Are you able to understand, ma? Mole ante number kada, inkem ledu. Mole is what? Mole is a number. Boldali? Very good. So 6.022 into 10 power 23 atoms or molecules or ions. This is called as a mole. So we always define energy, entropy, enthalpy, Gibbs energy, everything we calculate only for 1 mole only in the case of chemistry. Are you able to understand? ఒక atomకు ఒక moleculeకు define చేయాలి. Clear? That's it. Sima, see this question. Questions on change in entropy. Sima. So he is asking what is the entropy change in the fusion of 1 mole of a solid melting at 27 degrees Celsius is dash. These are the options. And the latent heat of fusion is already given. Are you able to understand? So first of all, let us see what is meant by change in entropy in the case of fusion, ma. So change in entropy in the case of fusion. Fusion means what? Fusion means solid converting into liquid. Clear, ma? Or liquid converting into solid. This is called as fusion. So it means question is based on what? Question is based on change of entropy in the case of phase transformations. Ikkada phases e kada change avutunnadi. Solid state it is converting into liquid state. So question is based on phase transformations. Are you able to understand, ma? So in phase transformation, whatever heat energy you supply, మీరు సప్లై చేసే టోటల్ హీట్ ఎనర్జీ ఏమవుతుంది? It is utilized for changing the phase only. That's what we have studied, no? In phase transformations, what happens? Whatever energy you supply, that will be converted to change the phase of the system only. Temperature of the system does not rise. Are you able to understand, ma? Okay. Next, let us see. Latent heat of fusion means what? Latent heat means, already we studied, no? Latent means hidden heat. It means to melt 1 mole of this particular material, how many joules is required? 2930 joules of heat energy is required. Adi dani artham. Artham avutundi kada ma? So latent heat means it is written as Q, the amount of heat energy you supply. Okay? Or you can write in small letters. Okay? This is how much? 2930 joules per mole. What is the meaning of this one? It means to melt 1 mole of this substance. ఒక మోల్ సబ్స్టెన్స్ను మెల్ట్ చేయడానికి ఎంత ఎనర్జీ కావాలి మనకు? వి రిక్వైర్ 2930 joules of energy. That is the meaning of latent heat. Are you able to understand, ma? Now directly apply the formula, which is the formula here. Delta S in the case of fusion is equals to, so Q in the case of reversible process divided by temperature of melting. Are you able to understand, ma? Q reversible is nothing but a change in enthalpy. Already we have studied, no? In the case of fusion divided by temperature of melting. Okay, ma? Change in enthalpy. In this condition, what is a change in enthalpy? Total heat energy supplied. Because the total heat energy you supply, it will not do any work. Adi work cheyadu. It totally is converted into changing the phase of the system. So here change in enthalpy is nothing but heat energy supplied. Already we discussed, no? అందుకే అన్ని పాయింట్స్ రాస్తున్నాను నేను. పాయింట్స్ ఊరిగా పనిలేక రాయలేదు, అప్లై చేయాలని. అర్థమవుతుంది కదా? సో రైట్ డౌన్. సో డెల్టా ఎస్ ఆఫ్ ఫ్యూజన్ is equals to, what is the heat energy supplied, ma? So 2930 divided by, what is the temperature given? 27, but it is in Celsius, no? Convert this one into Kelvin. So 273 plus 27. So 2930 divided by 300. Okay. Now once you do this calculation, value I am getting in terms of joules only. Because here heat is given in terms of joules only, no? And you have to check the units. Units also given in joules only, no? Joules are kilojoules, adjust చేసుకోవాలి ఫస్ట్. Kilojoules లో ఇవ్వలేదు కదా, joules లోనే ఇచ్చాడు. So you did not convert this one. Directly you can write the answer. So this is approximately 3000 by 300, 10 రావాలి. 10 కన్నా కొంచెం తక్కువ రావాలి. 10 కన్నా కొంచెం తక్కువ ఉన్నది అది. That is my answer. Okay, ma? So therefore 9.77 joules Kelvin inverse mole inverse. Are you able to understand, ma? So this is the unit of measuring change in enthalpy, ma. Change in enthalpy ki idi unit. Enthalpy gani, change in enthalpy gani idi unit. Okay. See, ma, in the formula what we have, only heat energy per temperature. Okay. So what should be unit? Nang unit en ravali? Joules per Kelvin. But again mole inverse is also there, no? Ante em arthamaindi meeku? Every calculation we do only for 1 mole only. Adi మీరు అర్థం చేసుకోవాలి. ఓకే మా? దట్స్ ఇట్. సో we will continue tomorrow, ma. So what is meant by spontaneous reaction, ma? The reaction which takes place suddenly without any external input is called as spontaneous reaction. Are you able to understand, ma? It means external input, external energy need not be supplied in this condition. Are you able to understand? Or you can say that when this spontaneous reaction occurs, energy will be released by the system. Energy will be released by the system. System releases energy. Are you able to understand? For example, how can you say, if I release this pen, I doesn't require any external energy to make this pen to fall down, no? So it falls down naturally. And this pen, is it releasing energy or not? Releasing energy. What kind of energy? So its potential energy is reducing, no, ma? Initially at this height it has some potential energy. Now when it reaches to the ground, its potential energy reduces. So it is releasing some kind of energy. Water always flows from high region to low region. This is a natural process. So such type of reactions which doesn't require any external input, they are called as spontaneous reactions. Are you able to understand? Now we study a very important parameter which is called as Gibbs free energy. Okay, ma? Gibbs free energy. So what is meant by Gibbs free energy? It is given by G is equals to H minus Ts. G is called as Gibbs energy. H is called as enthalpy of the system. Okay, ma? T is called as temperature and S is called as entropy. Are you able to understand? Okay, so what is this Gibbs energy? Or you can write delta G, change in Gibbs energy. Delta G means what, ma? Change in Gibbs energy can be written as, how I can write? Change in enthalpy minus T multiplied by change in entropy. So I can write like this also. Are you able to understand? So here I can write, so the change in Gibbs energy, the change in Gibbs energy is a measure of spontaneity of a chemical reaction. Okay, ma? It is a measure of what, ma? It is a measure of spontaneity of a chemical reaction. So how spontaneous a chemical reaction is, that is measured by what? That is measured by change in Gibbs energy. Are you able to understand? So here I can write down, see ma. So Gibbs energy is an extensive property. So a question can be asked on this also. Okay? Gibbs energy is an extensive property. What is meant by extensive property? In thermodynamics we studied, no? Extensive property means what? Extensive property means it depends on mass. Okay, ma? So if a property is depending on mass, it means if mass increases, Gibbs energy also increases. So such type of property is called as extensive property. Clear, no, ma? But Gibbs energy per mole, Gibbs energy per mole, this is an intensive property. Okay, ma? Gibbs energy per mole is an intensive property. What is meant by intensive property? Now already we have taken energy for 1 mole, no? Energy we have taken for 1 mole and it is always a constant. So now it doesn't depend on mass. So intensive property means what, ma? Now it does not depend on mass. Okay? Because we have taken specifically, no? Specifically. So in heat topic also we study, no, ma? Heat capacity depends on mass. Specific heat capacity doesn't depend on mass. Same concept here also. Gibbs energy depends on mass. Gibbs energy per mole doesn't depend on mass. Are you able to understand? Okay. Now here, when can I say that depending on Gibbs energy, whether a reaction is a spontaneous reaction or not? Clear, ma? So delta G, Gibbs free energy, if it is negative, okay, ma? Or change in entropy if it is positive. In these two conditions, reaction will be spontaneous. Are you able to understand, ma? So in which condition this reaction, chemical reaction, will be spontaneous, ma? When delta G is negative. Change in Gibbs free energy if it is negative, then chemical reaction will be spontaneous. Are you able to understand, ma? Delta S means what? S means what? Entropy. So change in entropy if it is positive, then also reaction will be spontaneous. And what is meant by spontaneous reaction already we have written, ma? Spontaneous reaction means what? So it happens without any external input, or when this reaction happens, there will be release of energy. Are you able to understand? That's it. Now, Sima, now let us study about this equation. So the equation of Gibbs free energy is H minus T into S. And what is meant by H already we have studied, no? H means what? Enthalpy is equals to total internal energy plus P into V. This is called as enthalpy, no? You should not forget this one. Enthalpy means the sum of total internal energy of the system plus the total work the system can do. Okay? The unit of work is, the formula of work is pressure into volume only, no? So total pressure multiplied by total volume. Are you able to understand? So this sum of U plus P into V is called as enthalpy. Okay? So change in enthalpy, how can I write? Change in enthalpy is equals to change in internal energy plus P, change in volume, P delta V. I can write like this. Already we studied in thermodynamics all these topics. Clear, no? So Now, in which condition a reaction will be spontaneous, ma? When change in Gibbs free energy is negative or change in entropy is positive. In these two conditions, reaction will be spontaneous. Now, let us study how Gibbs free energy can be positive or Gibbs free energy can be negative. So, in which process the reaction is spontaneous or in which condition it is not spontaneous. Okay, now see. So, delta G is equal here. So, everything, the sign of delta G should be what? It should be negative. Gibbs free energy should be negative, no? Then only the reaction will be spontaneous. So, this delta G will be negative and it depends on two conditions. What are the two conditions? One is the sign of delta H and the sign of delta S. Are you able to understand? So, right. So, the sign of delta G depends on what? Depends on signs of, okay ma, delta H and delta S. Okay. So, let us take both conditions ma. So, delta H and here I will write delta S. So, let us take one is positive, another one is also positive, first condition. Second condition positive, negative. Third condition negative, positive. Fourth condition negative and negative. Okay. So, in these four conditions we will try to understand whether delta G will be positive or not. Okay. If it is positive, it is not spontaneous, and if it is negative, then the reaction will be spontaneous. Are you able to understand? So, let us substitute each of them. Okay. So, let us take case number 1. Case number 1. What is case number 1? Delta H is positive, delta S is also positive. Are you able to understand? So, therefore, delta G is equals to delta H minus T into delta S. Are you able to understand? So, if both values are positive, then how can I write delta G is equals to plus delta H minus T into plus delta S. I can write like this now. This is the equation. Now, can you say in this condition delta G, can it become negative or not? ఇప్పుడు delta G negative అవుతుందా అవ్వదా చెప్పండి. Okay. So, what we have taken, delta H also positive, change in enthalpy is also positive. Okay, ma? Change in entropy is also positive. Both are positive. Then this is the equation which I get now. Now, by looking at this equation, can you say delta G, can it become negative or not? Because we want a negative value only, no? If delta G is negative, then only reaction will be spontaneous. Are you able to understand? No? Can delta G, can it become negative or not? No. It can become. In which condition it can become?
Delta S is more, sir.
Delta T is also there.
It is minus 1, sir.
So,
It can be minus 1 with sir.
in which condition delta G can become negative? That is my question. Can it become negative or not? Sima, this is 5, this is 2. 5 minus 2? 3. Value is positive. No? But if it is 5 and if it is 6, now can it become negative? Now definitely it will become negative. No? It means the magnitude of T into delta S should be greater than delta H. Clear, Nama? The value of T into delta S, if it is greater than delta H, then delta G will become negative. Are you able to understand? So, therefore, what I can write, okay, for delta G to become negative, magnitude of T into delta S should be greater than magnitude of delta H. I can write like this. Is it clear, ma? So, in this condition, now what I can say, delta G will be negative and reaction will be what, ma? Reaction will be spontaneous. Are you able to understand? So same types of questions will be asked in the examination. Are you able to understand? ఇవే క్వశ్చన్స్ ఇలాగే అడుగుతాడు ఎగ్జామ్. ఓకే, ఎందుకంటే కెమిస్ట్రీలో అంతకుమించి ఏం లేదు కాబట్టి ఇవే క్వశ్చన్స్ అడుగుతాడు. క్లియర్? Now see ma here, so therefore can I say that T is greater than delta H divided by delta S? Can I write like this? Okay. So if T into delta is greater than delta H, definitely I can write this relation. If delta is, if I send to the other side, then it will become delta H divided by delta S. And this temperature at which reaction will become spontaneous, this is called as spontaneous temperature, or the temperature at which the reaction will become spontaneous. Are you able to understand ma? So at this temperature, when temperature is greater than delta H divided by delta S, the reaction will be spontaneous. Are you able to understand? So make a note. So this temperature is the temperature at which reaction will be spontaneous. Are you able to understand me? Clear? Now let us try to apply the second case. Second case is what? Delta H is positive and delta S is negative. Are you able to understand me? Come on, first make a note up to here. Delta H is positive, delta S is negative. Are you able to understand? So here I have to write negative value. Okay. So negative value, what is the total answer I will get here? I will get, so delta G is equals to delta H plus T into delta S. This is what I get. And here temperature should be measured in Kelvin, no ma? Negative Kelvin possible అవుతుందా? Negative of a value of Kelvin, is it positive? Is it possible? Kelvin starts from 0 only kada. Minus 20 Kelvin is not possible. 0 Kelvin is possible. So temperature is not negative, delta S is not negative, delta H also not negative. Are you able to understand ma? So total value I got a positive value, so delta G is positive. So reaction is not spontaneous. Reaction is not spontaneous in this condition. Are you able to understand? Similarly, write the third condition. Okay. So what is case number 3 ma? Case number 3, negative positive. Okay. So this value I will take negative value and this value I will take positive value. Clear? So minus delta H minus of T into delta H. So what is the total value? So this is also minus, this is also minus. So definitely delta G will be negative and it is a spontaneous process. Are you able to understand? Delta G negative రావాలి, అదే కదా మనకు కావాల్సింది. So definitely this is a spontaneous process. Are you able to understand? Similarly, substitute the fourth case and see what is the answer you will get. Fourth case is negative negative. Substitute just student. So case number 4, negative negative. This is also negative and this is also negative. Clear nama? So negative and this value is also negative. So negative minus of minus will become plus. Are you able to understand? So now in this condition, delta G, can it be negative or not? Can it be negative?
Delta H ఎక్కువ ఉంటే
Magnitude of delta H should be greater than the positive value. If negative value is greater than positive value, then in that condition delta G will be negative. That's all. No? So here what is the condition? Delta H should be greater than T into delta S, then delta G will be negative and reaction will be spontaneous. Are you able to understand? No? So these are the different conditions in which a reaction can be spontaneous. Clear, no? Okay. So keep the next side heading. Okay, very very simple concepts, ma. Okay. So next we will study about standard Gibbs free energy. Okay ma? So Gibbs free energy at a particular temperature and pressure is called as standard Gibbs free energy. Are you able to understand ma? So what is the temperature? That temperature is 25 degrees Celsius and pressure is 1 atmospheric pressure. Are you able to understand ma? So at 25 degrees Celsius temperature and 1 atmospheric pressure, what is the Gibbs free energy? That is called as standard Gibbs free energy. Are you able to understand ma? So temperature is written in Celsius, no? If I want to convert into Kelvin, what I have to do? Kelvin loki marchalante 25 plus 273. So total how much ma? 298 Kelvin. Clear? So therefore at a temperature of 298 Kelvin and 1 atmospheric pressure, the Gibbs free energy is called as standard Gibbs free energy, and it is represented by this symbol, delta G degrees or dot or star, anything you can call it. Clear number? So therefore I can write, so standard Gibbs free energy is equals to, so delta H star minus T into delta S. Are you able to understand ma? So this is called as standard Gibbs free energy. Okay, just at a particular temperature and at a particular pressure. Which temperature and which pressure? 298 Kelvin and 1 atmospheric pressure. Are you able to understand ma? Now here there is one important point which we have to study about standard Gibbs free energy ma. Note point I will write down here. Note point is that at equilibrium, okay ma? We know what is meant by equilibrium of a chemical reaction, no? What is meant by equilibrium? Yesterday only we discussed. Equilibrium means what? The concentration of reactants and concentration of products, if it is not changing, then such type of reaction is called as equilibrium. Are you able to understand ma? So at equilibrium, Gibbs free energy will be 0. But standard Gibbs free energy may be 0, may not be 0. Okay ma? This is another important point which you should remember. Are you able to understand? So at equilibrium conditions, Gibbs free energy is 0 definitely. But standard Gibbs free energy may be 0, may not be 0. Clear nama? So then we write another important point. Okay ma? So standard Gibbs free energy is taken 0 for elements or molecules okay ma, when they are in their natural form, okay, or you can call this one as standard form. Are you able to understand? So Gibbs free energy is taken 0 for those molecules or atoms in which they are present in their natural form. Are you able to understand? Now let us see what is meant by natural form. Okay, Seema. Oxygen, naturally it is present in the form of gas, no ma? Oxygen natural ga gas form lo untunda, liquid form lo untunda, solid form lo untunda. Gas form there, no? So therefore its standard Gibbs free energy will be how much? It will be 0, because oxygen is present as O2 and in gaseous form in its natural form. Oxygen alage kada mana dorkedi. Clear now? But if you take H2O, here also oxygen is present, no? Here also oxygen is present. But is it in its natural form? No. So therefore, its Gibbs free energy is not 0. Okay. So here I have written elements or molecules. But molecule means molecules not made up of different elements. Molecules made up of similar elements. This is also a molecule and it is also in its natural form. Are you able to understand? But it is not made up of single element, it is made up of multiple elements. Hydrogen is also there, oxygen is also there. Okay. So for such elements we are not studying Gibbs free energy. Molecules which are made up of same element. Oxygen molecule, it is a molecule only, no? But it is made up of what? Same atoms of oxygen. For such molecules, and if they are present in a natural state, then definitely we can say their Gibbs free energy is taken to be 0. Are you able to understand? Ma? Similarly, same oxygen, if I take in a solid form, is its Gibbs free energy 0? Ma? Oxygen ni solidify చేసినాం అనుకోండి, గడ్డలాగా చేసినాం అనుకోండి, ఇట్స్ గిబ్స్ ఫ్రీ ఎనర్జీ 0 అవుతుందా అవ్వదా? అవ్వదు. ఎందుకలా? No, because it is not present in its naturalగా అది గ్యాస్ లాగా ఉంటుంది. క్లియర్ నమ్మా? సో దేర్ ఫోర్ ఇట్స్ గిబ్స్ ఫ్రీ ఎనర్జీ is not 0. Are you able to understand? For example, if you take hydrogen naturally it is present in gas form, nama? So its standard Gibbs free energy is 0. Are you able to understand? So like this you can write many substances. For example, if you take bromine, in periodic table we have bromine, no? Naturally is it solid, liquid or gas? Bromine is a liquid. Are you able to understand? Ma? Naturally it is present in liquid form. So therefore its standard Gibbs free energy is 0. Okay. Similarly, if I take sulfur, if it is present only in a rhombic form, then its Gibbs free energy is 0. Many other sulfurs are present. So monoclinic sulfur is present, but its Gibbs free energy is not 0. Similarly, triclinic sulfur is also present. Its Gibbs free energy also it is not 0. Are you able to understand? Ma? Similarly, I take phosphorus. Okay, white phosphorus only, its Gibbs free energy is 0. Okay, there are many phosphorus. So black phosphorus is there, red phosphorus is there. For of them, Gibbs free energy is not 0. Are you able to understand? Ma? Similarly, one more note point I can write here. Note point is that, okay, only one form of allotrope is taken 0. Okay, ma? So for example, carbon can have many allotropes, no ma? Ade kada ippudu meeku jarugutundi carbon chemistry. Many allotropes are there. Are you able to understand? Out of them, the allotrope of only one form is taken 0. Gibbs free energy is taken 0. For other forms it is not taken 0. Example is what? So if I take carbon, graphite form. So its Gibbs free energy is how much? Its standard Gibbs free energy is taken 0. Okay, ma? Carbon can be present in diamond form also, no ma? Diamond is also a form of carbon only, no? But its Gibbs free energy is not 0. Like this. So for same element, many allotropes are possible. Okay. But we take only for one allotrope we take as a measurement. For that one only we take standard Gibbs free energy 0. For the other allotropes, remember in the case of calculation of Gibbs free energy. Is it clear? Let us write one example. Clear, ma? Completed, no ma, up to here? So Gibbs free energy, standard Gibbs free energy in a chemical reaction. Standard Gibbs free energy in a chemical reaction. Are you able to understand? So if some chemical reaction is happening, then the change in Gibbs free energy in the case of reaction can be written as the change in Gibbs free energy in the case of products minus change in Gibbs free energy in the case of reactants. So this is the formula to calculate Gibbs free energy change in the case of a chemical reaction. Are you able to understand, ma? So standard Gibbs free energy change in the case of products minus standard Gibbs free energy change in the case of reactants. This is how we can write. Are you able to understand? Let us take one example. One example is, for example, methane naturally in gas form. Okay, it reacts with oxygen to release carbon dioxide and water. So I can write like this, no? Clear, no? So Sima, one very important point, note point here we have to write is all calculations must be done only in balanced reactions only. Okay, ma? Because when reactions are not balanced, everything will be wrong. ఖచ్చితంగా రియాక్షన్ని బ్యాలెన్స్ చేసే మీరు ఏదైనా ఫైండ్ అవుట్ చేయాలి. అది ఎంథాల్పీ కానీ, గిబ్స్ ఫ్రీ ఎనర్జీ కానీ, ఎంట్రోపీ, వాట్ ఎవర్ ఇట్. ఆర్ ఏబుల్ టు అండర్స్టాండ్, మా? నౌ ద రియాక్షన్ ఈజ్ ఇట్ బ్యాలెన్స్డ్, మా? 4 hydrogen, 2 hydrogen. So I will write 2 here. But 4 oxygens here, 2 oxygens. So I will write 2 here. Now the reaction is balanced. Are you able to understand, ma? So for this condition, how can I calculate the change in standard Gibbs free energy? ఈ రియాక్షన్కి ఎలా రాస్తాం చెప్పండి? అకార్డింగ్ టు దిస్ ఈక్వేషన్, హౌ కెన్ ఐ రైట్ స్టాండర్డ్ గిబ్స్ ఫ్రీ ఎనర్జీ చేంజ్? ఎలా రాస్తాం చెప్పండి? కంప్లీటెడ్ మా దిస్ వన్? ఓకే, ఎనీబడి కెన్ యూ సే? చెప్పండి. ఓకే, see ma, here CH4 means 1 into CH4, no? 1 into CH4 means what? 1 molecule of CH4 తీసుకోవచ్చా? But you should not take. Every calculation in chemistry must be done in moles only. నిన్ననే చెప్పినాను కదా, ఒక ఆటము ఒక మాలిక్యూల్ కాదు మనం తీసుకోవాలి, ఒక మోల్ తీసుకోవాలి. Are you able to understand, ma? So 1 mole of CH4 reacts with 2 moles of oxygen to release 1 mole of carbon dioxide and 2 moles of water. This is the method in which we have to take. Are you able to understand? So therefore, standard Gibbs free energy of the reaction, how can I write, ma? So the change in Gibbs free energy in the case of products minus the change in Gibbs free energy in the case of reactants. Are you able to understand? So these are the products and this is the reaction, no, ma? So write down. So how can I write down first CO2? How many moles of CO2 is released, ma? CO2. 1 mole of CO2 is released. So 1 multiplied by the change in standard Gibbs free energy in the case of CO2 plus, now what is the second product released? 2 moles of oxygen. So 2 multiplied by standard Gibbs free energy in the case of water, clear, no, ma? Minus of, now I have to write the change in Gibbs free energy in the case of reactants. Are you able to understand? So how many moles of CH4 is there? 1. 1 into change in standard Gibbs free energy in the case of CH4 plus how many moles of oxygen, ma? 2. 2 multiplied by standard Gibbs free energy change in the case of oxygen. So this is how I can calculate the total change in standard Gibbs free energy. Are you able to understand? Okay. Now see, ma, in this reaction, one change in Gibbs free energy is 0. What is that? మొత్తం 4 ఉన్నాయి కదా ఇక్కడ, 4 terms are present. For oxygen it is 0. Okay. Why oxygen it is 0? So this value is 0. What is the reason? Because this is oxygen and oxygen is present in its natural state. Are you able to understand, ma? Oxygen natural ga ela untundi, gas form lone kada undedi. So this is gas only. So standard Gibbs free energy change for this oxygen will be how much? 0. Okay. What about remaining terms? Are they in natural form? Carbon CH4 form lo undi, natural form lo unda లేదు. So its standard Gibbs free energy is not 0. Are you able to understand ma? Here also carbon is there. Is it present in its natural form? Carbon only if it is present in graphite form, then only its the standard Gibbs free energy will be 0. But here it is present in carbon dioxide form, it is not 0. Hydrogen, is it present in its natural form? No. Hydrogen naturally it is present in molecules in the form of gas. Clear no ma? But this is water. So it is also not present in its natural form. Are you able to understand ma? So like this you can write the change in total standard Gibbs free energy in the case of a reaction. Is it clear? That's it. Make a note undi. At any temperature. ఏ టెంపరేచర్ అయినా సరే
ఏ టెంపరేచర్ నెగిటివ్
నెగిటివ్ అవ్వదు, కానీ పెద్దది చిన్నది అవుతుంది కదా. బిగ్గర్ ఆర్ స్మాలర్ ఇట్ కెన్ బికమ్. పెద్దది చిన్నది అవుతుంది కదమ్మా. ఓకే, నౌ సీమా, దిస్ ఈస్ ద క్వశ్చన్. So of the following cases, identify the case in which spontaneous reaction is possible at any temperature. Starting లోనే చదువుకున్నాం కదా మనము. So delta H should be less than 0, delta H should be greater than 0. So that is the only case in which reaction will be spontaneous at any condition. Are you able to understand ma? So this is my answer. If you want the proof of this one, you can write down here. So delta G is equals to delta H minus T delta S. Are you able to understand? So delta H is negative, no? So minus delta H minus T into delta S. So total reaction is negative, no? Total value I got negative. So this is the only condition in which whatever may be the temperature, this value will be always negative. Are you able to understand? In other cases, depending on the magnitude of temperature, so reaction may be positive, it may be spontaneous, it may not be spontaneous. But this is total value is negative, no? So whatever may be the temperature is always positive, no? Temperature, if you measure in Kelvin scale, always positive. Okay? So whatever be the value of temperature, reaction will be always spontaneous because delta G will be always negative. Is it clear? So that is the condition. ఇందాక ఇక్కడ ఉన్నావు కదరా, బయట నుంచి ఎలా వస్తూ ఉన్నావు నువ్వు? శ్రీకృష్ణులాగా మాయమైపోయినావేమో అనుకున్నా. ఓకే, సో కెన్ యూ సేమ్? సో ఇన్ దిస్ కెమికల్ రియాక్షన్ delta H is 150 kilojoules, change in entropy is also given, temperature is 300 Kelvin. Then what is the delta G for this reaction? Very tough question. Clear no ma? So delta G is equals to delta H minus T into delta S. Delta H, change in enthalpy is how much? 150 kilojoules. See, my options are also given in kilojoules. You need not convert here. Directly you can write down. Minus temperature is 300. Delta S is 100 joules per Kelvin. Are you able to understand? Okay. So here value is given in joules, no ma? But options are given in kilojoules and delta H is also given in kilojoules. So therefore you convert this one in terms of kilojoules. Okay, so 150 kilojoules minus of, so 3 zeros will make a kilo, no? So therefore 30 kilojoules per Kelvin. Okay, now everything converted into kilojoules only, no? So therefore 150 minus 30 is how much, no? 120 kilojoules is the change in delta G. That's it. Very, very tough question. Clear, no? So the next topic which we are studying is heat of reaction or you can also call it as enthalpy of reaction. Okay ma? So it means that heat and enthalpy we are using as synonymous terms, no ma? Rendu oke terms ga vaadta unnam. And that is possible in which condition? Heat and enthalpy, they are equal when pressure is a constant. This point you should always remember. Are you able to understand, no? See ma, in any chemical reaction, pressure always remains constant, no? In most of the conditions, pressure remains constant. When reaction is happening, pressure remains constant. Are you able to understand? So when pressure is a constant, the heat supplied to the system are removed from the system, which is called as heat exchanged. It is equal to the total change in enthalpy of the system. So heat anna enthalpy anna same అవుతుంది. ఏ కండిషన్లో ప్రెషర్ కాన్స్టెంట్గా ఉన్నప్పుడు. సో బరాబర్ కరెక్ట్. Are you able to understand now? So when pressure is a constant, heat exchanged and the change in enthalpy both are equal. That is the reason why I can write, either I can write heat of reaction, the heat exchanged in a reaction, or just you can write the enthalpy of reaction also. Enthalpy అంటే ఏందో పదం అనుకుని కన్ఫ్యూజ్ అయిపోకండి. హీట్ అన్నా ఎంథాల్పీ అన్నా రెండు ఒకటి. ఏ కండిషన్లో? when pressure is a constant, and in almost every chemical reaction pressure will be constant. Understood now? And what is meant by enthalpy? Already we studied many times now. Again we are discussing here. So enthalpy is equals to the total internal energy of the system plus the product of pressure into volume. U means what here? U means internal energy, and internal energy depends on what? Internal energy depends on temperature. If temperature increases, internal energy also increases. Clear now? So if I want to change in enthalpy కావాలంటే, so change in internal energy plus change in work done, that is the total amount of work done. So work done can be written as T into delta V. Are you able to understand? And according to ideal gas equation, we know PV is equal to nRT, no? According to ideal gas equation, PV is equal to nRT. So therefore instead of P delta V, I can write a delta Mg RT also. Okay? And what is meant by delta Mg? This is the fourth time we are discussing. What is meant by delta Mg? In a chemical reaction, so the number of gaseous moles, take only gaseous moles only. That means moles of only gaseous atoms only we have to take. Number of gaseous moles of products minus number of gaseous moles of reactants, that will give delta Mg value. In entropy we studied, if delta Mg is positive, entropy is also positive. If delta Mg is negative, entropy is also negative. Are you able to understand? That's it. So this is about the heat exchanged in the case of a reaction. Are you able to understand? So heat of reaction again is of three types. Clear? So right now. So heat of reaction, or you can call it as, so heat of reaction is of three types. Are you able to understand? What is meant by heat of reaction? We have understood now. So heat exchanged in a reaction is called as heat of reaction. That's it. Clear now? So definition I did not write now. So here I will write down heat exchanged in a reaction is called what? This is called as heat of reaction, or you can call it as enthalpy of reaction. Are you able to understand? So reactions can be basically of three types now. Reactions ఎన్ని రకాలు ఉంటాయి? మూడు రకాలు ఉంటాయి. ఏవేవి? క్లియర్ నా? So one is formation, second one is neutralization, okay ma, and the third one is combustion. Okay, and some other processes also may be present. So heat of reaction basically I can divide into three types. Clear nama? Reactions ఇదే కదా మనకు ఉండేది. So neutralization can happen in a chemical reaction. If you combine acids and base, they will neutralize with each other. No? That is a type of reaction. Okay? అగ్గిపుల్ల తీసుకొని కిరోసిన్ మేము వేసినట్టే మండుతుంది. అది కూడా ఒక రియాక్షనే కదా. That is type of combustion. Are you able to understand? And when some new elements or new compounds are forming, then that is called as reaction in the case of formation. Are you able to understand? So reactions, they are of three types, and some more reactions also may be possible. So remember up to here, then we will continue in the next class. Neutralization. Now beautiful writing studying is heat of formation. So what is meant by heat of formation? The amount of heat energy exchanged. Exchanged means either released or either absorbed. In which condition? When 1 mole of substance is created by their constituent elements in their natural form, in their standard form. Are you able to understand? Now let us, already we have studied what is meant by standard form. For example, hydrogen exists in gaseous form, that is its natural form. Hydrogen does this exist in liquid form? No, in its natural form. So that is not the standard state. Similarly, if you take bromine, bromine is a liquid at room temperature. Naturally, it is a liquid at room temperature. So that is its natural form. But its solid form or gaseous form, it is not its standard form. Are you able to understand? So see here, whatever definition we will write, these definitions are very, very, very important. If you don't remember the definitions, you cannot do the problems also. Everything is the game of definitions here in this topic. Are you able to understand? So therefore, the amount of, how much amount of substance formed? 1 mole of substance formed. Are you able to understand? By which type of atoms or which type of molecules? The atoms or molecules which are present in their natural state. Only such type of molecules if they react, and then the amount of energy exchanged. Either energy may be released or either energy may be absorbed also. So that amount of energy we can call it as heat of formation or enthalpy of formation, because already we have studied when process is constant pressure process, then heat and enthalpy both are same. Clear, Nama? Okay, now see. For example, if I take an example of clear, ma? So H plus plus OH minus, it gives rise to H2O, Nama? Are you able to understand? So here the amount of energy either released or absorbed, can I call it as heat of formation? Huh? So hydrogen ion plus OH ion, they are reacting to form water. So here some amount of energy may be released or some amount of energy may be absorbed. So that amount of energy, can I call it as heat of formation or not? Huh? H plus is it in its natural form? Hydrogen ఇలాగే H plus లాగా ఉంటుంది, ఎక్కడ చూసిన గాల్లో మీకు ఉండదు కదా. So this is not correct, because here hydrogen, even OH minus, they are not present in their natural form. Are you able to understand now? Then how water can be formed? So H2 plus O2, they give rise to form H2. This is the natural form. Are you able to understand now? So how many hydrogen are there? Only 1 hydrogen. So half mole of hydrogen. 1 mole of hydrogen reacts with half mole of oxygen to form H2O. So here the amount of energy either released or absorbed, that is called as heat of formation. And elements should be present only in their natural form. Are you able to understand? Similarly, how can I write the heat of formation in the case of a chemical reaction? Okay, so note point. In the case of a chemical reaction, okay, in the case of a chemical reaction, delta Hf, the heat of formation of chemical reaction, can you say how can I calculate? How can I calculate? So it is the heat of formation of products minus heat of formation in the case of reactants. So while describing heat of reaction also, same equation we have written, no? So here also I can apply the same relation. Are you able to understand? So the total heat of formation of reaction, how can I calculate? The heat of formation in the case of products minus heat of formation in the case of reactants. This is how I can calculate. Are you able to understand? So many times questions were asked on this particular equation. So you should remember this one. Okay. So next one which we study is standard enthalpy of formation. Okay, ma? Standard enthalpy of formation. So it is written somewhat like this, HF, there is one symbol here, degree symbol. This is called as standard enthalpy of formation. Okay. Now can you say what is meant by standard enthalpy of formation? In the last class we discussed, no? Standard enthalpy of formation means what?
Its original state. Its original state.
No. Standard enthalpy of formation means the enthalpy of formation at a temperature of 25 degrees Celsius and 1 atmospheric pressure. That is called as standard. Standard Gibbs free energy we have studied, no? What is standard Gibbs free energy? Gibbs energy at a temperature of 25 degrees Celsius and 1 atmospheric pressure. Same concept here also. Are you able to understand? So therefore what I can write? So enthalpy of formation at 25 degrees Celsius, or you can call it as 298 Kelvin and 1 atmospheric pressure. Okay, ma? So this amount of heat energy exchanged in the system at what temperature? At a temperature of 25 degrees and 1 atmospheric pressure, that amount of heat energy in a reaction is called as standard heat of formation. Are you able to understand, ma? That's it. Okay. Now here standard heat of formation is taken 0 for elements in their natural form. So that I will write here. Clear, ma? So note point. Notice the note point. Clear, ma? Note point is that standard enthalpy of formation, you can call it as delta HF star, is taken 0 for elements, molecules, in which form, ma? In their natural form. Are you able to understand? And what is meant by natural form? Yesterday we have made a simple list, in the last class. Okay, same list you can apply here also. So what was the list we have studied? For example, if you take hydrogen, if it is in gas form, clear, nama? Then delta HF star value will be how much? It will be 0. Clear? For example, if you take oxygen in gaseous form, then it is 0. If you take oxygen in liquid form, then it is not 0. For example, if you take H2O liquid, is it 0 or not 0? It is not 0, because hydrogen natural form is hydrogen gas only. Clear, nama? Similarly, oxygen natural form is O2 gas only. But this is not a natural form. This is definitely a compound. Naturally it exists in universe, but it doesn't mean this hydrogen and oxygen, they are present in the natural form. No. Okay, ma? Here molecules means what? This is also a molecule. But I am discussing about which molecules? The molecules which are made up of same atoms. Understood, nama? O2 molecule, no? Made up of what? Same atoms. It's okay. So that type of molecules I am discussing. This is also a molecule, but it is not made up of same atoms. It is made up of different atoms. Are you able to understand, ma? That's it. So like this you can, same list we have studied in the last class, no? Same list you can write here also. Bromine always exists in liquid form. So only standard heat of formation for bromine in liquid form only, it is 0. So like that you can write sulfur. For only rhombic sulfur it is 0. Okay, ma? For monoclinic sulfur it is not 0. For triclinic sulfur it is not 0. Phosphorus, only for white phosphorus it is 0. Remaining all forms of phosphorus it is not 0. So only for elements in the standard form only it is 0. Otherwise it is not 0. Clear? That's it. Okay. So this is about heat of formation now. Okay. And again I am writing the most important note point, which you should always remember. All calculations should be done. All calculations should be done only for 1 mole itself. Okay, ma? So every calculation we do for what? Every calculation we do for only 1 mole of chemical substance which is formed. Now see. So therefore this is the chemical reaction which is given now. So we are supposed to find out the standard enthalpy of formation in this particular chemical reaction. Clear, nama? Zinc, natural state is solid form. Oxygen, natural state is gaseous form. And they are reacting to form Zn, zinc oxide. Clear, nama? Then the heat of the standard enthalpy of formation for the case of zinc is minus 210 kilojoules per mole. Okay. So here we assume that 1 mole of zinc is reacting with half mole of oxygen and 1 mole of ZnO is formed. Are you able to understand? No, sir. So therefore standard heat of formation in the case of a chemical reaction, how can I write, ma? Standard heat of formation in the case of products minus standard heat of formation in the case of reactants. Are you able to understand? So what is the product which is formed? Product is zinc oxide. This is the what you call product which is formed. Okay. Now the question is, this product which is formed, is it present in its natural state or not? Zinc natural state is Zn1, na? కాదు కదా. Zinc natural state is solid form. Just Zn, that's it. Clear, no? So therefore, its standard heat of formation or standard enthalpy of formation, is it 0? Is it 0 or not? No, it is not 0. Why it is not 0? Because only if elements or atoms or molecules, if they are present in natural form, then only standard heat of formation is 0. It is not present in a standard form now, so therefore it is not 0. And the data is already given. Okay, ma? What is the data? Minus 210, minus of. Now coming to reactants. In reactants, what we have? We have zinc, which is present in its natural form. We have oxygen also, which is present in natural form. So 0 plus 0. Clear now? So therefore answer is minus 210 kilojoules per mole. Okay, that's all. This is about the heat of formation in the case of zinc. Understood now? Heat of reaction, first one we have studied now, heat of formation we have studied. Second one is heat of neutralization. So what is meant by heat of neutralization? First of all, I have written, this is an exothermic process. Exothermic process means here always energy will be released. Okay, ma? When an acid and when a base, when they react together and salts are formed, when they neutralize, energy is always released. Are you able to understand? So this is an exothermic process. So what is the definition of heat of neutralization? So go through the definition very, very carefully. So see what he has written. Amount of heat energy released when 1 mole of H plus ions react with 1 mole of OH minus ions to form 1 mole of water. Are you able to understand? So in this condition, the amount of energy released, that is called as the heat of neutralization. This is a neutralization reaction only, no? Acids and bases, they are reacting to form a neutral salt. So that is why it is called as heat of neutralization. Okay. For example, if I take this reaction, if I take HCl, clear, no? Plus NaOH, clear? So this is a strong acid, no? Ca means what? Strong acid. This is a strong base. Clear, no? So when one strong acid, when a strong base reacts, then what is the product you will get? You will get NaCl plus H2. This is what you will get, no? You will get NaCl, sodium chloride plus water is released. This is the reaction which happens. Clear, no? So when you mix both of them immediately, then immediately what happens is ionization will happen, or you can call it as dissociation will happen. What is meant by ionization? Ionization ante, so HCl, first of all it should split into H plus and Cl minus, no? Are you able to understand? HCl is a molecule, but if you want to react with the case of a base, first of all it should split into its respective ions. That is what first of all should happen, no? So HCl, first of all it splits into H plus and Cl minus. Similarly, NaOH, it also dissociates into Na plus and OH minus. So here the H plus, Cl minus and Na plus, which are dissociated, they react together to form the salt. And remaining H plus and OH minus, they react to form water. Water will be created. Are you able to understand? So therefore, in this one, which is the required dissociation for me, here the required dissociation which I require to calculate the heat of neutralization is H plus. That is what I require now. Because here what is the definition I have written? 1 mole of H plus ions. So in NaCl, I require only H plus. Are you able to understand, ma? And it reacts with NaOH. And in NaOH, what I require? OH minus. Clear, no, ma? And both of them react to form water. Okay. So here the amount of heat energy released is, you can call it as minus 13.7 kilocalories of heat energy. What is meant by minus symbol? Minus symbol indicates what? Energy is released. Already we discussed in the last class, no? If energy is positive, it means that you are giving energy to the system. Positive energy ante meaning emi? Energy meer istunnarani. Negative energy means energy is released out of the system. Okay, ma? So the final temperature of the reactants which is released, its temperature rises. Final temperature పెరుగుతుందా తగ్గుతుందా? Final temperature పెరుగుతుంది, ఎందుకు ఎనర్జీ రిలీజ్ అయింది కదా, అండ్ ఎనర్జీ విల్ బి రిలీజ్డ్ ఇన్ ద ఫార్మ్ ఆఫ్ హీట్ ఎనర్జీ. ఓకేనా? రియాక్షన్ జరుగుతుంది, అడుచుకుంటా సౌండ్ ఎనర్జీలో కన్వర్ట్ అవ్వదు కదా, అది ఎనర్జీ మస్ట్ బి కన్వర్టెడ్ ఇన్ టు హీట్ ఎనర్జీ. అండ్ ఆ హీట్ ఎనర్జీ ఎక్కడికి పోతుంది? ప్రొడక్ట్స్లోకే పోతుంది. Are you able to understand, ma? So finally, the temperature of NaCl and H2O will be greater. It increases. Are you able to understand, ma? So this is the amount of energy released. In which condition? When one strong acid, one strong base, when they react together, this is the amount of energy which is released. Okay, ma? Sometimes question may be given in kilojoules also. Okay, we know that 1 calorie is equals to 4.2 or exactly 4.12 joules, no ma? 1 calorie approximately 4.2 joules. Exact ga kavalante 4.180 joules. So multiply with this one. So 13.7 multiplied by 4.18. Just cheppandi answer. I think approximately 57.3 kilojoules. I think approximately we will get this much answer. I don't know exactly. Approximately you will get this answer. Are you able to understand, ma? So question can be asked in the case of kilocalories also. Question can be asked in the case of kilojoules also. So both you should be careful. Are you able to understand? So therefore, one more example if you want to write, you can write HNO3 plus KOH. They react to form what, ma? KNO3 plus H2O. Okay, ma? So this is another neutralization reaction. So very strong acid, okay, ma? And this is a strong base, and this is the salt which is created, and this is the water. And how much amount of energy will be released, ma? Minus 13.7 kilocalories of energy will be released. Are you able to understand? So make a note of this point. What is the note point we have to write? If a strong acid and a strong base, okay, ma? When they react, then for every 1 mole of water, 1 mole of water formed, how much energy will be released, ma? 13.7 kilocalories, or you can call it as 57.3 kilojoules of energy is released. Are you able to understand? And these are the values only for strong acid and strong base only. Clear? And what is the specialty of strong acid and a strong base, ma? Strong acids and strong base, they dissociate very easily. They ionize very easily. Are you able to understand? But if you take a weak acid or a weak base, then their dissociation is quite tough when compared to strong acid and strong base. So therefore, in such conditions, this much amount of energy cannot be released. Are you able to understand, ma? For example, if you take a weak acid, strong base, strong acid, weak base, weak acid, weak base, one of them is weaker, no? Then in that condition, this much amount of energy cannot be released. So that energy will be always less than 13.7. Are you able to understand? So let us make a note of that point also. Is it clear, ma, what is happening here? So therefore, okay, when any one product, when any one reactant is weaker, okay, then energy released is less than energy released is less than 13.7 kilocalories. Are you able to understand, no? Is it clear? Okay. Reason. What can be the reason for this one, ma? Reason also, if you remember, then immediately when you see the reaction, you can understand what is happening. Reason is what? Reason is sum of the energy released, clear number, is utilized for dissociation or ionization of weak acid or weak base. Clear number? So are you able to understand what is happening now? Why the energy released is less than 13.7? ఎందుకు ఎనర్జీ తక్కువ అవుతుంది చెప్పండి? Energy released in the process is 13.7 only, but final energy will not be 13.7. What is the reason? Because the sum of the energy which is released, that will be useful for dissociating the weaker acid or weaker base. Because weaker acid and weaker base, it is not easy to dissociate. No? అది డిసోసియేట్ హెచ్ ప్లస్ గాను ఓహెచ్ మైనస్ గాను డిసోసియేట్ అవ్వాలి అంటే దానికి ఎక్స్ట్రా హీట్ ఎనర్జీ మీరు సప్లై చేయాలి. అర్థమవుతుంది కదా? అండ్ ఫ్రమ్ వేర్ ద రియాక్షన్ విల్ గెట్ దట్ ఎక్స్ట్రా హీట్ ఎనర్జీ? సో ఫ్రమ్ ద ఎనర్జీ రిలీజ్డ్ బై ఇట్ సెల్ఫ్. ఓకే, ఇట్ ఈస్ రిలీజింగ్ 13.7 ఫర్ ఎవ్రీ 1 mole of water formed. No? Same energy will be taken by either weak acid or weak base or both. And some of the energy is used for dissociation, that is splitting of H plus or OH minus. Are you able to understand? Let us write one example. So symbolically we will write strong acid plus weak base. Okay ma? Next, weak acid plus strong base. Weak acid plus weak base. Okay. So in these three conditions, so the heat of neutralization is less than 13.7 kilocalories. Symbolically if you write, I hope you can understand now. So in these conditions, the heat of neutralization, it is not 13.7, it is less than 13.7. Okay, let us write one example. Clear now? So very well known example which you have been studying from your school days onwards. Okay, so CH3COONA plus NaOH, it reacts to form CH3COOH COONA plus H2. So this reaction we know, no? Are you able to understand? CH3COOH, what is the name of this acid? Acetic acid. Strong acid or weak acid? Weak acid. Clear no? NaOH, strong base or weak base? Strong base. Clear no? So therefore weak acid plus strong base, they react together to form those products. Are you able to understand? And here the amount of energy released is minus 11.7 kilocalories. Okay ma? Amount of energy is how much released? No, only 11.7 kilocalories of energy is released. But if it is a strong acid and a strong base, then how much energy will be released? 13.7. But here 11.7. So 13.7 minus 11.7, 2 kilocalorie per mole. What happened to that energy? Energy that energy is utilized for dissociating CH3COOH into CH3COO minus and H plus. Dissociation ki use avutundi. Are you able to understand ma? So therefore what is the note point here? I have to write note point is that. Clear ma? So 13.7 minus 11.7 is equals to 2 kilocalorie per mole. Clear ma? Is utilized for dissociating CH3COOH into H plus and CH3COO minus. Are you able to understand? So this is what is happening in this particular condition. Clear now? Okay. అర్థమవుతుంది కదా? Okay. So therefore this same 2 kilocalories of energy per mole, this is called as heat of ionization also. ఈ ఎనర్జీ అయాన్స్ని మార్చడానికి, అయాన్స్గా మార్చడానికి యూజ్ అవుతుంది కదా. దిస్ ఎనర్జీ ఈస్ యూస్ఫుల్ టు కన్వర్ట్ CH3COOH, which was a chargeless molecule, into charged molecule, the molecule which is having charges. Are you able to understand? So therefore this energy itself we can call it as heat of ionization. Are you able to understand? Therefore 2 kilocalorie per mole is called what? Is called heat of ionization. Are you able to understand? Clear? అర్థమవుతుంది కదా ఏం జరుగుతుందో. When it is a strong acid and a strong base, then can you say what is the heat of ionization? Heat of ionization, 0. There is no heat of ionization. Are you able to understand, ma? But if any one of them is weaker, then some of the energy is utilized for converting the weaker acid or weaker base into constituent ions. For that some of the energy is utilized. That utilized energy itself is called as heat of formation. Are you able to understand, ma? So therefore what is the definition of heat of formation? I can write. Questions illa kuda adutadu. Heat of neutralization నేర్చేసుకున్నాం కానీ సంకలు గుద్దుకుంటే సరిపోదు అనమాట. Heat of ionization కూడా నేర్చుకోవాలి. Clear? So therefore what is the definition of heat of ionization, ma? Sum of the energy utilized out of 13.7 kilocalories per mole for ionization of weak acid or weak base. Clear now? This is called as heat of ionization. Okay. So if I want to write this one in the form of an equation, how can I write? I can write. So heat of ionization is nothing but 13.7 minus heat of formation, heat of neutralization. Can I write like this one? So in this condition, what is the heat of neutralization? 11.7. Only magnitude wise only we will write here. Okay, without signs. Signs we don't take here. Are you able to understand? So heat of 13.7 is the value which is released when acid is strong, base is also strong. Up to 13.7 release. But if any one of them is weaker or both are weaker, then the heat of neutralization will be less than 13.7. That difference itself is called as heat of ionization. That is how we have to remember. No? So therefore I can write 13.7 minus 11.7 is how much, ma? 2 kilocalories per mole. Okay, ma? Or I can write 2 into 4.18 kilojoules per mole. Okay. That is called as heat of ionization. Okay. So from a heat of neutralization only, heat of ionization is also produced. Okay. That's it. Make a note up to here. See ma here. So this is a given question, ma. So X ml of strong acid HCl reacts with Y ml of strong base NaOH to form salt and water. And the rise in temperature for this condition is 10 degrees Celsius. Okay, ma? It means the salt and the water which are created, their temperature rises by 10 degrees Celsius when compared to the temperature of the products. Reactants. Reactants temperature to compare cheste product temperature 10 degree ఎక్కువగా ఉంటుంది. Clear? So when how much ml of HCl is taken? X ml. But in the second case I am taking 10x, 10 times more volume of HCl, 10 times more volume of NaOH, and if they react, then how much will be the rise in temperature? 10 degrees only. Same 10 degrees. So, Sima, if you are increasing the volume of HCl, more energy will be released definitely. So when 1 mole releases, let us take X to be 1 mole. When you take 1 mole, and if you take 1 mole of NaOH also, then 13.7 energy will be released. 10 times if you are taking, for example, if you are taking 10 moles of HCl and 10 moles of NaOH, then energy released will be definitely 10 times greater, 10 into 13.7. But at the same time, mass is also increasing now. Mass kuda perigindi kada. So if mass is also increased, so mass has increased by 10 times. Heat energy also increased by 10 times. Then why temperature will change? Temperature will not change. Temperature, same amount of rise in temperature. First case 10 degrees rise, second case also rise in temperature of 10 degrees. So by concept of specific heat, I can understand now S is equals to Q divided by M delta T. Okay. So delta T is a change in temperature, no? So I can write Q by M into S. I can write like this one. So Q by M ratio, if it is constant, change in temperature also is a constant. Q means heat energy, M means mass. Heat energy released rises by 10 times. Mass also rises by 10 times. Then change in temperature does not change. Change in temperature will be same 10 degrees Celsius. Okay, ma? So write down case number 1. Case number 1, what you can write, delta T is equals to Q by M into S. Specific heat concept we know, no? Amount of heat energy required to raise the temperature of unit mass of a body by unit rise in temperature is called as specific heat. Clear? So in case number 2, delta T is, let us call it as delta T1, delta T2. So it is a 10Q divided by 10M into S. Heat energy released raised by 10 times, mass also raised by 10 times. 10 and 10 cancel ayipothe malli ade vastundi kada. So therefore what I write, delta T1 and delta T2 both are same. Okay ma? ఈ క్వశ్చన్ ఇంతకుముందు చాలాసార్లు అడిగినాడు. మన అద్భుతమైన పిల్లలు ఏం చేస్తారంటే 10 టైమ్స్ పెరిగింటుందని 10 into 10, 100 అది కూడా ఉంటారు ఆప్షన్లో, దరిద్రమే ఒకటి ఆప్షన్ పెట్టేస్తారనమాట. మార్కులు రాకపోగా ఉండే మార్కులు ఓడిపోతాయి అన్నమాట. సల్ఫ్యూరిక్ యాసిడ్ చాలా స్ట్రాంగ్ యాసిడ్ అది. ఓకే, స్ట్రాంగెస్ట్ యాసిడ్ ఏమో నైట్రిక్ యాసిడా? HNO4 ఉంది, ఎక్కడ ఉంది? సల్ఫ్యూరిక్ యాసిడ్ అది, HNO3 nitric acid. Okay, so see here. So what is the given question? 1 mole HCl and 1 mole H2SO4. We have to neutralize these two acids. HCl is an acid, no ma? H2SO4 is also acid. So I want to neutralize these two acids by using NaOH, sodium hydroxide, which is a base. Are you able to understand? And you have lot of NaOH. మీకు ఎంత కావాలంటే అంత NaOH ఉంది. But HCl and H2SO4 you have only 1 mole. Are you able to understand, ma? So if energy released in neutralizing HCl is A kilojoules and in neutralizing H2SO4 the energy released is B kilojoules, then what is the relation between A and B? That is the question. Okay. Now first of all let us take first reaction. Okay. Which is the first reaction here? Clear, ma? HCl plus NaOH, they should neutralize. Then what are the reactants which will form? NaCl plus H2. This is what is created. Are you able to understand? Now see. So each HCl molecule, it will release 1 H plus ion. Clear now? And from each NaOH, 1 OH minus ion will be released. Okay. So both of them, they react together to form 1 H2O molecule. That's it, no? Or you can call 1 mole also. 1 mole HCl releases 1 mole H plus. 1 mole NaOH releases 1 mole OH. And 1 mole of water is formed. Are you able to understand? So everything is in terms of 1 mole only, no? Therefore how much energy will be released? So delta hat of neutralization is how much, ma? Minus 13.7 kilocalories of energy will be released. Are you able to understand? Okay. Now let us go to the second reaction. Clear? So in the case of second reaction, now what is happening, ma? H2SO4 should react with NaOH to form NaSO4 plus H2O. This is the reaction which should form. No? Are you able to understand? Equation, is it balanced? No. Equation is not balanced. Are you able to understand? So therefore, how to balance this equation? See here, H2 releases how many H plus ions? It will release 2 H plus ions. Are you able to understand? And 2 H plus ions requires 2 OH minus ions also. No? ఒక H plus neutralize అవ్వాలంటే ఒక OH ఉంటే చాలు. 2 H plus are there. So 2 OH minus also should react. So therefore, I have to write 2 here, 2 NaOH. Are you able to understand? So therefore, this will give now 2 moles of OH minus ions. So 2 moles of H plus, 2 moles of OH will give how much water? 2 moles of water. Are you able to understand now? So therefore, they will give rise to 2 moles of water. Okay. So here A value is how much? Minus 13.7. But here B value is how much? It is 2 into minus 13.7 kilocalories of energy. Why I am writing 2 into minus 13.7? Because here only 1 mole water is formed, but here 2 moles of water is formed. So definitely energy released will be double. Okay. So now check the options. So answer is actually B is equal to 2E. Options lo undadi లేదు. So this is not correct. A is not greater than B. A is not equal to B. A is less than B. This is my option. That's it. Understood now? So the point is that you have to concentrate on definitions. Definitions are very important in chemistry. Definition perfect ga mind lo arthamaindante calculations you can do very easily. Understood? That's it. ఒక మోల్ H ప్లస్ ఒక మోల్ OH తో రియాక్ట్ అయ్యి ఒక మోల్ వాటరే ఫామ్ అవ్వాలి. Then the amount of energy released is minus 13.7. Understood, no? That's it. So see now. So heat of combustion, or you can call it as enthalpy of combustion. What is meant by combusting? Combusting means what? Burning anything, oxidizing anything. Okay, ma? Or electrical arcing also you can call it. So therefore, what is meant by heat of combustion? See, if you burn anything, energy will be released, no? So this is also an exothermic reaction. Are you able to understand? So the amount of energy released when how much a compound is burnt, 1 mole of compound is completely burnt, or if it is oxidized, or it is electrically arced. This is called as the heat of combustion. Are you able to understand? For example, if I take CH4, are you able to understand, ma? CH4, when it reacts with oxygen, then it forms what? Then it forms CO2 plus H2O. This is what is formed. And in addition to that, how much amount of energy will be released? So minus 212 kilocalories of energy per mole. This much amount of energy will be released. CH4 means methane. So if you burn 1 mole of methane in oxygen, then this much amount of energy will be released. Okay. And if you want to convert this one in terms of kilojoules, 1 calorie is equals to 4.18 joules. So approximately you will get 890 kilojoules per mole. Are you able to understand? So this amount of energy released, we can call it as heat of combustion. Okay. So how much amount of fuel or how much amount of compound we are burning? 1 mole of compound we have to burn. Then the energy released is called as enthalpy of combustion or heat of combustion. Are you able to understand? And see now, whenever in the reaction you see C, always it forms a CO2. If you have carbon in that compound, అర్థమవుతుందా? కాంపౌండ్ లో కార్బన్ ఉంటే, and when you oxidize that particular compound, what is the final reaction, final product which will form? CO2. Always CO2 will be formed. Okay. We are saying this because the combustion reactions మీరే రాయాల్సి ఉంటుంది ఫైనల్గా. కంబషన్ రియాక్షన్స్ వాడేవాడు ఈ రెండు రియాక్ట్ అయితేనే కంబషన్ రియాక్షన్ నువ్వే రాసుకొని క్యాలిక్యులేట్ చేయండి అంటాడు వాడు. సో వెన్ ఎవర్ కార్బన్ ఈస్ ప్రెసెంట్ ఇన్ ద కాంపౌండ్, ఇట్ ఫైనల్లీ కన్వర్ట్స్ ఇన్ టు CO2. క్లియర్ అమ్మా? Similarly, whenever hydrogen is present, water will be formed. Whenever sulfur is present, SO2 will be formed. Whenever nitrogen reacts, NO2 may be formed, or NO also may be formed, but this is the general molecule. Which one? NO2 is the general molecule. Are you able to understand, ma? So this minimum you have to remember. Whenever you see carbon, CO2 will be formed, hydrogen H2O will be formed. Able to understand now? And when sulfur is present, sulfur dioxide SO2 will be formed in the case of combustion reaction. Clear? So make a note of this point. So what is the note point you have to write now? We have to write combustion reactions. Okay? If they are not given. If they are not given. If combustion reactions are not given, then we have to write the combustion reactions, and minimum these values you have to remember. Clear now? So then I will write the heat of reaction or enthalpy of reaction in terms of heat of combustion. Are you able to understand now? So that is heat of combustion I am trying to write in the case of a chemical reaction. Okay. So therefore in a chemical reaction, how can I write? In a chemical reaction, okay ma? So delta H of chemical reaction is equals to, so delta H of reactants minus delta H of products. And this is a very, very, very important relation. Able to understand? It was because previously in all the enthalpies what we were writing ma? Previously what we were writing? We were writing that heat of reaction is equals to delta H of products minus delta H of reactants. But here in the first time what we are writing? Delta H of reaction is equals to delta H of reactants minus delta H of products. Are you able to understand? So this point you should not forget. Are you able to understand ma? So the heat of combustion in the case of reactants minus heat of combustion in the case of products. Is it clear? That's it. Okay. So after this we study another parameter which is called as calorific value. Okay ma? So calorific value. So what is meant by calorific value? The amount of energy released, clear, when 1 gram of fuel is burnt. This is called as calorific value. Are you able to understand ma? So what is the difference between heat of combustion and calorific value ma? Heat of combustion means what? There we are burning 1 mole of any compound or 1 mole of fuel. But here calorific value means what? We are burning only 1 gram of fuel. Then what is the amount of energy released? That is called as calorific value. Are you able to understand? What does calorific value indicate? If calorific value is greater, clear, then the class of a fuel is higher. Okay ma? If calorific value is greater, it means that that fuel is belonging to higher class. For example, we have kerosene, we have petrol used for aircrafts. Everything is its same. Petrol bike lo nadipinarante inta poga vastadu annamata. Calorific value will be lesser. Calorific value of petrol is greater. Calorific value of the fuel used in aeroplanes, it is much better. Able to understand? It means for every 1 gram of fuel you are burning, if it is releasing more amount of energy, it means that its calorific value is greater. Same is the concept with the case of heat of combustion also. Able to understand? See ma here. So CH4 plus oxygen, when they are reacting with each other, then the amount of energy released is 120 kilojoules per mole. Okay? And when C2H6 and oxygen, when they are reacting with each other, then the amount of energy released is 420 kilojoules per mole. It means 1 mole of CH4 is reacting, 1 mole of C2H6 is also reacting, and this is the respective energies which are released. Now the question is, which is a better fuel? So better fuel is indicated by what? Better fuel and ela cheptaru. If its calorific value is greater, then you can say it is a better fuel. That's all, Rama. So therefore we are supposed to find out the calorific value. Okay. And calorific value always we calculate for 1 gram only, no? Calorific value we calculate for 1 gram. Okay. Now you take first reaction. Okay. In the first reaction, which is the compound we are burning CH4. Are you able to understand? So what is its molar mass? Molecular weight or molar mass, both are same. Molecular mass is how much? So carbon is 12, no? Hydrogen H4 is 4. So total how much? 16 grams. Now what is the meaning of 16 grams? 16 grams ante molecular weight anna, molar weight anna anta okate. Are you able to understand, no? So molar weight is 16 grams means what? What do you understand? 16 AMU ki 16 grams ki unna difference emi. What is meant by 16 AMU and what is meant by 16 grams? ఇప్పటికి 14 సార్లు చెప్పినాను ఇప్పటికే నేను షార్ట్ టర్మ్ నుంచి చెప్తానే ఉన్నా చెప్పండి డిఫరెన్స్ బిట్వీన్ 16 సేమ్ ఐ కెన్ రైట్ ఇట్ as 16 AMU ఆల్సో సో ద అటామిక్ మాస్ ఆఫ్ కార్బన్ ఈస్ 12 అటామిక్ మాస్ ఆఫ్ హైడ్రోజన్ ఈస్ 1 బట్ 4 atoms are there, no? So 4, so 12 plus 4 I can write 16 AMU also, atomic mass units or unified mass, or I can write 16 grams also. So what is the difference between 16 AMU if I write, that is the mass of single molecule of CH4. ఒక్క molecule తీసుకున్నాం అనుకోండి, if I take only one molecule of CH4 and molecular masses they are measured in AMUs if I take single molecule, atomic mass units. Okay, ma? But the same value if I write it as 16 grams, then what is the meaning of this one? This is the mass of 1 mole of CH4 molecules. Grams lo raste dan artham emi? It means we are taking the mass of 6.023 into 10 power 23 molecules. The mass of those many molecules is how much? 16 grams. Adi artham. Are you able to understand, ma? If you are writing molecular mass in AMU, then that is the mass of only one molecule, one molecule of CH4. But if you take 1 mole of molecules, mole means what? 6.023 into 10 power 23 molecules కలిపి మాస్ తీసుకుంటే అది దేంట్లో వస్తుంది? అది గ్రామ్స్లో వస్తుంది. AMU is a very small quantity, no? Grams is a very big quantity. AMU means single molecule, grams means for 1 mole of molecule. Are you able to understand, ma? So therefore 1 mole of CH4 if I burn, then how much energy is released? Then 120 kilojoules of energy is released. Are you able to understand? Therefore for 1 gram of CH4 how much energy is released? 16 grams of CH4 if I burn, then I am getting this much energy. Ante kada 120 kilojoules of energy I am getting for 1 mole of CH4 molecules if I burn them completely. Okay, but if I want to burn only 1 gram of CH4, then how much energy will be released? How I have to calculate? 120 divided by 16, that's all, no? 16 grams ki inta energy release aithe 1 gram ki 16 to divide cheyali kada, anta energy release avutundi. Okay, and this is its calorific value. So this is the calorific value of methane. Because calorific value is measured for 1 gram only, no? I have taken 1 gram. Are you able to understand, ma? Similarly, what is the molecular mass of C2H6, ma? See here, I am writing second reaction. So in the second reaction, which is the molecule which I am taking? C2H6. So C2 means carbon 12, 24. 24 plus 2 is how much, ma? 26 gram. Huh? HO? Sorry, H6, no? H6. H6 means 24 plus 6 is how much, ma? 30 grams. Are you able to understand? It means 1 mole of C2H6 if I take, how many molecules, ma? 1 mole of C2H6 molecules if I take, then what will be their combined mass? 30 grams. Are you able to understand? It means 30 grams of C2H6 if I react, if I burn them in oxygen, then how much energy is released? 420 kilojoules of energy is released. For burning 1 gram of C2H6, so 1 gram of C2H6 if I burn, then the amount of energy released is 420 divided by 30. For 30 grams this much energy. For 1 gram you have to divide by 30. That's all. No? So find out which value is greater, C2H6 is greater? Yes, this is a bigger value. Are you able to understand? So definitely C2H6 is a better fuel. Are you able to understand? Calculate change. Calculate to see which one is the bigger value. Idi peddadara?
Yes sir, minus 14, 7 point something.
This much is how much you will get? Huh? 7.5 something. This one? Minus we will leave. What is the value? 14. Definitely this is a bigger fuel. Its calorific value is greater, no? So C2H6 is a better fuel when compared to CH4. That's it. Understood, Dhamma?
Sir, can you
Negative means what is meant by negative? Negative indicates that energy is released, that's all. Negative indicates that energy is released, that's it. Plus indicates that you have to supply energy. మండుతుందంటే అర్థం ఏమి ఎనర్జీ రిలీజ్ అవుతా ఉందనే కదా అర్థం. మరి ఏది బాగా మండిందంటే దాని ఎనర్జీ ఓకేమా. సో సి వాట్ ఈస్ ద డెఫినేషన్ వీ హ్యావ్ రిటర్న్ మా. సో ద అమౌంట్ ఆఫ్ heat energy which is utilized or absorbed to form what? To form 1 mole of gaseous atoms. How many atoms should be formed? 1 mole. Gaseous, liquid form or solid form? Gaseous atoms should be formed. Okay. From where? From their constituent elements or molecules in their standard form. Are you able to understand? So elements or molecules, they should be present in their standard form. What is meant by standard form? Already we have studied. Oxygen is present in gaseous form in standard state. Bromine, it is present in the form of liquid in standard state. Are you able to understand? Sodium, it is present in solid form in solid state, that is in a standard state. Are you able to understand? So these atoms or molecules, if I want to convert into gaseous molecules, and how many molecules? 1 mole of molecules. And what is the raw material? The atoms or molecules which are present in their standard state. Then the amount of energy which you have to supply, that is called as heat of atomization. Are you able to understand? So is it an endothermic reaction or exothermic reaction? Endothermic reaction, because it absorbs heat energy. You have to supply heat energy, no? Otherwise the molecules which are present in either gaseous form or what you call liquid form or solid form, they cannot be converted into gaseous form. You have to supply energy in this condition. Are you able to understand? So therefore, what is the meaning of this? Let us see. So oxygen, gaseous form, this is in its natural state, no? Oxygen O2, when it is present in gaseous form, this is the natural state or not? Is the natural state? Clear, no? So this one you have to convert into this is atom or a molecule? This is a molecule. Molecule you have to convert into 2 oxygen atoms in which form? In gaseous form. Then the amount of energy which is absorbed, that is called as delta HE. Are you able to understand? Clear, number? Similarly, if I take one more example, bromine. Bromine naturally it is present in liquid form, Br2 molecule. Okay. So therefore this I have to convert into 2 bromines. Are you able to understand? And they have to be converted in which form? Gaseous form. Then the amount of heat energy which is absorbed, that is called as heat of atomization. Are you able to understand? Now see here, how many moles of oxygen is reacting? 1 mole. But how many? This 20 kada this 20 2O is this. 2 times the oxygen. Are you able to understand? 2O means what here? 2 moles of oxygen is formed. Not 1 mole of oxygen is formed. But what is heat of atomization? To form 1 mole of gaseous atom. So here the amount of energy released will be 2 times the heat of atomization, because 2 moles of oxygen is formed. No? మనం ఎన్ని మోల్స్కి చదువుతా ఉన్నాము? టు ఫార్మ్ 1 mole of gaseous oxygen. But here how many moles are formed? 2 moles of gaseous oxygen is formed. So therefore here the amount of energy absorbed is how much? 2 times the heat of atomization. Are you able to understand? Here also same concept. 1 mole of bromine, 1 molecule, it is getting separated into 2 atoms. That's what is happening, no? Bromine lo enni atoms untayi? Rendu separate ga vellipotayi kada. When it converts into gas form, 1 atom will be traveling in this direction, 1 atom will be traveling in this direction. So 1 molecule of bromine, it will give 2 atoms of bromine. So how many moles of bromine is formed? 2 moles of bromine is formed. So here also the heat of atomization will be how much? 2 times the heat of atomization in the case of bromine, because 2 moles are formed. Arthavatuna definitions. That's it. Are you able to understand, ma? So here we have to make some note points. Note points are that in the case of metals, okay, ma? In the case of metals, so heat of atomization is equals to heat of sublimation. So these two will be equal in which condition, ma? In the case of metals. What is meant by sublimation? Sublimation ante? Solid form directly converting into gaseous form. So there the amount of energy which is utilized, that is exactly equal to heat of atomization. In which case? In the case of metals. Sodium metal ni తీసుకున్నాము. Are you able to understand, ma? Sodium metal ni బాగా heat చేస్తాకే the direct gas గా మారిపోయింది అనుకోండి. Then the amount of energy supplied is nothing but heat of sublimation. No? So that heat of sublimation and heat of atomization in the case of same sodium, they are equal. Because sodium is a metal. In the case of metals, this is always satisfied. Are you able to understand? HYA means what? Heat of atomization. Okay. Heat of S means what? Heat of sublimation. Sublimation means directly solid converting into gaseous form. That is called as heat of sublimation. Are you able to understand, ma? That's it. This is one more point. Clear? One more note point is that in the case of single bond molecules, okay, ma? Heat of atomization is equals to half of bond enthalpy. Okay, or you can call it as enthalpy of bond dissociation energy. Bond dissociation energy, or also you can call it as heat of bond dissociation. Are you able to understand, ma? So this is another point which you should remember. Okay. In the case of single bond molecules, what is meant by single bond molecules? Okay, ma? H2 gas converts into 2H gas. So this is a single bond molecule only, no? Between hydrogen, how many bonds are present? Between 2 atoms of hydrogen, how many bonds are there? Only 1 bond is there. So when 1 bond is present, then the heat of atomization is how much? It is half of the bond enthalpy. What is meant by bond enthalpy, we will study. Bond enthalpy is also called as enthalpy of bond dissociation energy. Clear, Nama? Enthalpy of bond dissociation energy is also called as heat of bond dissociation or heat of bond dissociation energy. Okay, no? So these are the 2 note points you should remember. In the case of metals, heat of atomization and heat of sublimation, both are same. In the case of single bond molecules, so heat of atomization is only half of heat of bond enthalpy. Are you able to understand, ma? That's it. Okay. So now we will try to define what is meant by bond enthalpy or heat of bond dissociation energy. Make it up. So in the following reactions, iodine is converting into iodine in gaseous form. Clear? Similarly, zinc is also converting into zinc atoms into gaseous form. Okay. So out of these chemical reactions, in which reaction HYA means what? Heat of atomization. Heat of atomization is equals to heat of sublimation. Chappandi. Yesterday only we have discussed this one under some note points. Note points. In the case of metals, Juveria చెప్పింది ఏం చేస్తున్నారా మీరంతా? Okay, ma? Sima. We discussed, in the case of metals, heat of atomization and heat of sublimation, they are equal. So out of iodine and zinc, which one is a metal? Zinc is a metal. So definitely this is my reaction. So therefore, in the case of metals, clear? What can I write? Heat of atomization is equal to heat of sublimation. Okay. So based on that also questions can be asked. That's it. Make a note of this one. Okay, ma? So next we study about the next enthalpy, which is called as bond enthalpy. Okay, ma? Or you can call it as bond dissociation energy. Okay, ma? Or you can call it as enthalpy of bond dissociation. Okay. So in questions it can be asked on these different names. It can be called as a bond enthalpy also, bond dissociation energy also, or enthalpy of bond dissociation also. Okay. So by looking at the what you call this heading only, you can say, Nama, what is the meaning of this heat energy which you supply? Can you say, anybody? Bond breaking. Very good. Energy required for bond breaking. Clear? How many bonds we have to break? Already I said you that in this total chemistry, always we study quantity in terms of 1 mole only. Okay, ma? So the amount of energy required to break 1 mole of covalent bonds into gaseous atoms is called as bond dissociation energy, or enthalpy of bond dissociation. Okay, so write down the definition. So the amount of heat energy required, okay, ma, to convert 1 mole of, or to break, that is better, to break 1 mole of covalent bonds, okay, ma, into gaseous atoms. And atoms also should be in which form? They should be in gaseous form. We are not discussing in liquid form, we are not discussing in solid form. Are you able to understand? No? We have to break the bonds and we have to convert those atoms into gaseous form. Then that amount of energy required is called as bond enthalpy or bond dissociation energy. Are you able to understand? For example, between hydrogen and hydrogen, what kind of bond is present? Covalent bond is present. No? Are you able to understand? No? So this converts into 2H again, which is present in. Are you able to understand? No? Clear? Gaseous form. So here the amount of energy required is called as delta Hb. The amount of energy required for breaking 1 mole of covalent bonds. Are you able to understand? Similarly, I can write a chlorine in gaseous form if I want to convert into 2Cl, clear number, again in gaseous form. Then the amount of energy required is called as bond enthalpy. Clear? Similarly, bromine, which is in liquid form naturally, it should be converted into 2Br, again in gaseous form. Then the amount of energy again required is called as bond enthalpy. Are you able to understand? So this is the definition of bond enthalpy. Now see ma, here, how many moles of oxygen we are converting, ma? We are breaking. How many moles of hydrogen we are breaking? 1 mole of hydrogen we are breaking. Clear, no? But how many moles of gaseous hydrogen is formed? 2 moles of gaseous hydrogen is formed. For example, 10 molecules of hydrogen if I break, they convert into 20 atoms of hydrogen. That's all. ఒక molecule and hydrogens ఉంటాయి. If I break 1 molecule, 2 atoms will be created. Similarly, if I break 1 mole of hydrogen, 2 moles of hydrogen gaseous atoms will be formed. And yesterday we studied heat of atomization. No? What is heat of atomization? What is meant by heat of atomization? No? Amount of energy required to form 1 mole of gaseous atoms. But here how many moles are formed? 2 moles are formed. So therefore what will be the total energy? So 2 times of heat of atomization. That's all. No? Because 2 moles of hydrogen in gaseous form is formed. A form lo undali final ga. Finally it should be present in gaseous form only, no? So 2 moles of gaseous hydrogen is formed. So therefore the energy required for this process will be 2 times the heat of atomization. Are you able to understand, ma? But here how many moles of hydrogen we are breaking? 1 mole. And for breaking 1 mole of covalent bond, what is the energy required? Bond enthalpy, or you can call it as bond dissociation energy. Okay, ma? So in this condition, the amount of energy required is delta Hb, bond dissociation energy. Okay. In this condition, the amount of energy required is, are you able to understand how much it is? It is 2 times of heat of atomization. Are you able to understand what is happening? Is it clear, ma? So for breaking this one, bond enthalpy, but forming 2 moles of gaseous atoms, 2 times of heat of atomization. So therefore this energy and this energy is exactly same, no? Are you able to understand? Yesterday also we had a small discussion on this one. So therefore what I can write, so bond enthalpy is exactly equal to 2 times of enthalpy of atomization, or you can call it as heat of atomization. So this is an important point. Are you able to understand, ma? Similarly, write one note point. Okay, so if more than one bond is broken, more than one bond is broken from same molecule, then at each breaking, different energy is required. Okay, ma'am? So we take the average of all energies, and that energy is considered what? Bond enthalpy. Are you able to understand, ma? Clear? For example, if I have a molecule and many bonds are present, many covalent bonds are present. Are you able to understand? So first of all, I am breaking one bond. Then I require some energy. So if I want to break a second bond also, I require more energy or less energy? More energy. Why? Because already one bond is broken, no, ma? So it has gained some charge now. So to break another bond, I require more energy when compared to the first energy. Are you able to understand? Similarly, if I want to break one more bond, then again different energy is required. Are you able to understand? But then which energy I have to consider to be the bond enthalpy? 3 bonds break chesam oke molecule. First ది తీసుకోవాలనా, సెకండ్ దా, థర్డ్ దా, ఏది తీసుకోవాలి? Just you take the average of all the bond enthalpies, that will be the bond enthalpy of that particular molecule. Are you able to understand? Let us write one example now. Okay. For example, if I take methane, CH4 if I take, clear? Then CH4, how I can write? It can be split into CH3 plus H. Clear, nama? So here some amount of energy will be released, no? Let it be delta HB1. Clear? Then from CH3, again I will form CH2 plus H. Clear, nama? And here the amount of heat energy required is delta HB2. CH2 is converted into CH and H, and here the amount of heat required is delta HB3. So CH is finally converted into C plus H, then the amount of heat energy required is delta HB3. Are you able to understand? All of them, they are covalent bonds only. So in each breaking, I require different amounts of energy. Then which is the bond enthalpy in this condition? Then the bond enthalpy in this condition is delta HB1 plus, delta HB2 plus, delta HB3 plus, delta HB4 divided by 4, because we are taking the average of all the bond enthalpies. Are you able to understand, ma? So this is one note point which you should remember in this condition. Okay. Write another small data, ma. Right. So heat of reaction in terms of bond enthalpy. Heat of reaction in terms of bond enthalpy. So heat of reaction can be written as bond enthalpy in the case of reactants minus bond enthalpy in the case of products. Okay, and this is a very, very important equation. Are you able to understand, ma? See, ma, here also we have written in opposite form. Do you remember? Clear, na, ma? So in heat of combustion also we have written heat of combustion of reactants minus heat of combustion in the case of products. So in bond enthalpy also we are writing the same thing. Are you able to understand now? So heat of reactants minus heat of bond enthalpy in the case of products. And all the previous conditions, what we have written, heat of reaction is equals to heat of products minus heat of reactant. Those, in these two conditions, you have to write reactants minus products. Understood now? Okay. See this question. So bond enthalpies of hydrogen, oxygen and OH are 105, 120 and 220 kilocalories per mole respectively. Are you able to understand now? Then what is the heat of reaction, and this is the reaction which is given. And which heat energy he is asking us to find out? Bond enthalpy. Heat of formation he is not asking. Heat of neutralization he is not asking. He is asking bond enthalpy. That is the amount of energy required to break these bonds. Are you able to understand? And in the case of breaking, which is the equation ma? Heat of reaction is equals to, so bond enthalpy of reactants minus bond enthalpy of products. Are you able to understand? So what are the reactants here? Hydrogen and oxygen, they are the reactants. Okay. How many moles of hydrogen is reacting ma? 2 moles of hydrogen is reacting. Are you able to understand? So therefore we write 2 times of, and what is the bond enthalpy of hydrogen ma? 105. Clear? Plus, next, how many moles of oxygen is reacting? 1 mole of oxygen is reacting, and for oxygen what is the value? 120. Minus of the bond enthalpy in the case of products. And which is the product which is created here? Hydrogen. No, sorry, water. Okay, ma? And in water what kind of covalent bonds are present? OH bonds are present. In water OH bonds are present, no? So therefore minus of, how many moles of water is formed? 2 moles of water. And for each mole of water, what is the amount of energy required? 220. Clear, Nama? So therefore, now do the calculation. 105 into 2 is how much, ma? 210 plus 120 minus how much? Huh? Which one into 2, ma? Ah, yes, 4 bonds are present now here. OH bonds, how many OH bonds are there? 2 OH bonds are there. So totally how much, ma? So 4 into 220, 88. Clear? So therefore minus 880 plus 330. So how much, ma? So minus 550 kilocalories. That is the amount of energy required. Are you able to understand? So this is the point which we forgot, ma. In hydrogen, how many OH bonds we have? 2 OH bonds are present. Are you able to understand? So therefore 2 times the energy is required. And 1 more 2 why we are writing here? 1 more 2 we are writing because 2 moles of water is created, no? That's all. That is how we do the calculation. Are you able to understand? That's it. Okay. Now see. So next we are studying about heat of fusion, heat of vaporization and heat of sublimation. All of them, they are related to changing of states only, no? Solid state converted into gaseous state, liquid state converting into gaseous state. So all of them, they are related to each other. So we are writing under the same heading. So therefore what can be heat of fusion? Heat of fusion means melting process, no? Or solidifying process, anything you can say. Clear? So what is happening in this condition, ma? Solid, it should convert into liquid, okay? Or liquid can also be converted into solid. And this process, either from solid to liquid or liquid to solid, it occurs at same temperature. Temperature does not change. Are you able to understand, ma? So I can write change in temperature is how much? 0. But there will be some particular temperature. And what is that temperature called as? That temperature is called as melting point, or you can call it as freezing point also. Both are same. Melting point in the sense solid is converting into liquid. When liquid converts into solid, it is called as freezing point. Melting point of water, 0. Freezing point of water, 0. Both are same now. Are you able to understand, ma? Melting point and freezing point both are same. They occur at the same temperature. So therefore, how much amount of solid should be converted into liquid, ma? Again 1 mole, because we do every calculation for 1 mole. So 1 mole of solid, if it should be converted into liquid, at which temperature? At melting point. Then the amount of energy released or amount of energy absorbed, that is called as heat of fusion. Are you able to understand? And that is represented by delta HF, fusion. Okay. Now similarly, can you write the same type of equations for vaporization also? Okay, come on, write down. So heat of vaporization, how can you write? Same type of equation. Heat of I will do one thing. I am a very intelligent person. I will change here only. Completed ma this one? So heat of vaporization. Okay. So the amount of energy required or released to convert 1 mole of liquid into gas or steam at boiling point. Instead of melting point, I have to write boiling point. Then it is called as what? It is called as heat of vaporization. So here liquid is converted into gaseous form, or you can call it as steam, or steam can be condensed into liquid also. Are you able to understand now? For example, if you take water you can convert into steam. At what temperature? At a temperature of 100 degrees Celsius. At the same 100 degrees Celsius, steam can be condensed into water also. Okay? At this temperature we can call it as boiling point. And here the amount of energy either utilized or released, that is called as delta H vaporization. Okay ma? So delta H vapor. Are you able to understand? Okay. Similarly, what is meant by heat of sublimation ma? To convert into gas directly. So if solid directly converts into gas bypassing the liquid form, then that type of energy required is called as sublimation. That process is also called sublimation. Are you able to understand ma? So write the third definition. So therefore heat of sublimation. Okay. So the amount of energy required to convert 1 mole of a solid into gas at a particular temperature. At a particular temperature. That is called as heat of sublimation. Okay, ma'am? So here a solid should be converted into gaseous form. Okay. Then this amount of enthalpy we can call it as delta H sublimation. And the beautiful point is that delta H of sublimation is equals to delta H of fusion plus delta H of vaporization. Okay. Are you able to understand ma? So heat of sublimation will be equal to what? Heat of fusion as well as heat of vaporization, because here solid is converting into liquid form. Here liquid is converting into vapor form. Here directly that is happening, no? So definitely if you add this energy and this energy, then only you will get this total energy. Are you able to understand ma? That's it. So that is about heat of fusion, vaporization and sublimation. So next we study about heat of hydration, or you can call it as crystallization also. Crystallization, okay ma? Dilution and solution. Okay. So heat of hydration, heat of dilution and heat of solution. Are you able to understand ma? So first of all we will write what is the definitions of hydration, dilution and solution ma? Clear? So what is meant by hydration or crystallization? Are you able to understand? See ma, if you take any powder form of any chemical substance and if you add a required amount of water, it converts into solid form. We should have observed this one. No? So మన వంట సామాగ్రిలో కూడా పొడిగా ఉన్న దాంట్లో వాటర్ వేసినారు అనుకోండి, అది క్రిస్టల్గా మారుతుంది. Are you able to understand ma? So that amount of water required to convert any substance into crystal form, that is called as heat of crystallization. Are you able to understand ma? So what is meant by crystallization? Exact amount of water required, or you can say water molecules required, clear ma? To convert into crystal form is called what? Is called as heat of hydration. Sorry, the process of hydration. Are you able to understand ma? Then what is meant by dilution? Okay ma? if water molecules are more than required amount for crystallization or hydration, then it is called dilution. Are you able to understand now? So required amount of water molecules, if they are more than required for crystallization. For example, if I require 5 water molecules for crystallization, are you able to understand ma? But I am adding 50 water molecules. So there is extra water molecules now, then that process is called as a dilution. Are you able to understand? Then the third process is called as solution. So what is meant by solution? Solution means, clear? If infinite water molecules are added, then it is called what? Then it is called solution. Are you able to understand? Okay. So that is the difference between hydration, or you can call it as crystallization, and dilution and solution. Just you are adding a required amount of water molecules, it is called crystallization or hydration. More than that you are adding, that is dilution. So you are adding a very huge number of water molecules, then it is called as solution. That is the difference. Understood? No? Let us take an example of this one so that we can understand what is happening in this condition. So sigma. So for example, CuSO4, it requires only 5 water molecules, then it will form CuSO4, 5H2O, and crystal will be formed. CuSO4, copper sulfate crystal will be formed. Okay, ma? So each molecule of CuSO4 requires how many water molecules? 5 water molecules. Then the crystal of CuSO4 will be formed. Then what is this process called? E process name antamu. This process is called crystallization. Okay, ma? Or you can call it as hydration. And here the energy released is called as heat of crystallization or heat of hydration. If you want water molecule, some energy may be released, no? That amount of energy released, what we call it as, it is called as heat of hydration. Are you able to understand, ma? So energy released in above process is called what? Is called heat of hydration. Are you able to understand, ma'am? So just you are adding the required amount of water molecules. There is no water molecule extra. Then the amount of heat released in this process is called as heat of crystallization, or you can call it as dilution. Hydration. Clear? In the next process, what I am doing is I am taking CuSO4 and I am adding 50 water molecules. Clear, ma'am? Then it forms what? Then it forms a CuSO4 50H2O, or the same one I can write it as CuSO4 5H2O, clear, no, ma? And 45H2O. So I can write like this. Are you able to understand? So for each CuSO4 molecule, actually only 5 molecules of water is required. But how many water molecules I am adding? 50 water molecules I am adding. Then this reaction can be written like this also, no? Okay. CuSO4 5H2O is the required process for hydration. But additionally, how many water molecules I have? 45 water molecules are present. Are you able to understand? This process up to here, what you call this one, ma? This is called as hydration. Clear, no? And this total process is called as dilution. Okay. Understood, no? Similarly, next what I am doing is, clear, no? So CuSO4 plus 1000 water molecules are added. Okay. Then the reaction, how I can write CuSO4 1000 H2O. Clear? Same reaction I can write CuSO4 5H2O, and I can write 45 H2O, and again I can write so 950, no, 950 H2O. So I can write like this. Are you able to understand? Clear now what is happening? So therefore, CuSO4 5H2O, what is the name given? Hydration. So from up to here it is called as hydration. Clear? CuSO4 45H2O, it is called as dilution. CuSO4 and 1000 H2O, it is called as solution. Okay, ma? And energy released in each process, that is called as heat of dilution, heat of hydration, heat of dilution, and heat of solution. That's it. Are you able to understand, ma? So this completes our topic, which is called as thermochemistry. Clear? So tomorrow we will start the topic of what, ma?